Hello, people. Levi here from Bright Young Brains. What we are going through today is the 2023 Maths Grade 12 NSC question paper 1 from start to finish. So please take note that as of this recording, the official memo is not available anywhere. So if I do make a few mistakes here and there, please just bear with me. You can just let me know in the comments and I'll do the best I can to try and rectify any of those mistakes. So from the start, we have a very simple question here. I haven't done this in quite a while, so I hope you will bear with me regarding this particular recording, but this is back to basics, so let's just see what we can do. Solving for x, we don't exactly have much of a challenge here. This looks like a question where we can just solve for x by factorizing. So we need factors of 12, right? That will give us the coefficient in front of x here. So we need factors of 12 that can give us a 1. So factors of 12 that can give us a 1, if we add or subtract them together, that's clearly just 4 and 3. So we have 4 here, we have 3 there. Now to get a positive 1, we have to have been saying positive 4 minus 3. So this is what we have if you factorize this expression. So both brackets, we equate each individually to a 0. So this is our second bracket, also equal to 0. Now, simply put, our answer here is negative 4. Our answer here is positive 3. Nothing too difficult here because the 4 goes to the other side, it becomes a negative. The 3 goes to the other side, it becomes positive. And with solving for x, you are better off always testing your answers. So if you put negative 4 in your equation here, it should give you a 0 because negative 4 squared is going to give you a 16. And then if you subtract 4, it's going to give you a 12, and then 12 minus 12 gives you a 0. So your answer is correct. Moving on to the next one. Anytime you're going to see that your answer requires you to have two decimal places, 99.99% of the time, if not 100% of the time actually, you firstly want to make sure that you put your equation into standard form, because only once you have put it into standard form can you work it out using the quadratic equation. So b squared minus 4ac in brackets, under the square root symbol there. This formula, you can get it on your formula sheet at the back of your question paper. So our b here is clearly negative 2 here squared. Our a value is positive 3, and then our c value is negative 6. So while I go through these question papers, I won't sometimes go too deep into explaining some of the questions, but if you do need assistance when it comes to deep explanations, you can always visit the link in the description. It will take you to the online courses on our website, or you can always message me on Instagram, and I'll do my best to try and respond. So here we're going to have two answers of x from our calculator. So again, since the official memo is not out, all these questions here, I do have to work it out manually. In most instances where the memo is available, I'll work out up until the final answer, and then I'll just test if what I have is correct. But for now, I don't have any safety net per se, so I do have to be careful. The best way to be careful is to test the answers when we have gotten them. So here we have 1.79 if you round it off. Then the other answer, if you replace the plus here with a negative in your calculator, we are getting probably a negative number. So we have negative 1.12 if you round it off. So what I would actually suggest you do is the current answer that's on display in your calculator right now, put that where x is in the original equation. So we have 3, and then we're throwing in our answer in our equation. And then the idea is to see if we get a 0 on the other side. And we do. So as long as one of the answers is correct, chances that this other one is also correct are very high in a situation like this one. So if you were to test using 1.79 and you put that there, you would get an answer maybe very, very close to 0, because this is rounded off, and that will be okay to say that your answer is correct. In the next question here, for 4 marks, it is a very common thought to think that here you're going to get 2 answers, but one of them is not going to be valid. And this is very common for cases where your original question has a square root symbol there. So in a situation like this, the first thing you would want to do is to square both sides so that you get rid of the square root symbol. So here you're going to have 2x plus 1 equal to your first bracket, or rather this bracket multiplied by itself. So x multiplied by x, that's going to give you x squared. X multiplied by -1, that's going to be negative x. And then another negative x, and then a positive 1 here. So from here, we can clearly see that solving for x is not a challenging thing to do. It's quite straightforward. X squared minus 2x here. And then let's bring this to the other side, right? Minus 2x also. If we bring this to the other side, it's going to be -1. And then the +1 over there. So this minus 2x and this -1, it's this that we have moved to the other side. So simplifying further, we are having here x squared. This is going to give us negative 4x. And then a -1 plus a 1 gives us a 0. So that being said, let's see what we can do next. So here, fortunately, we can actually just factorize by taking out x as a common factor. So x being out as a common factor, we're going to have our answers x is equal to 0 or x minus 4 is equal to 0. So this is giving us x is equal to positive 4. So as mentioned, in situations like these, you definitely do want to test out your answer. Otherwise, you're going to end up with one answer that is correct and one answer that is wrong. So if you sub in a 0 into your original equation, right, we will have 2 times 0, which is a 0, and then square root of 1 is just a 1. Here, if you have 0 minus -1, you have -1. And -1 is not the same as positive 1, so 0 is not a valid answer. If you put a 4 into the original equation, 2 times 4 would have given you 8. 8 plus 1 is a 9. Square root of 9 is a 3 on this side. And then here, if you put a 4 here minus 1, it's also a 3. So the 4 is valid. So you keep this answer and you disregard the 0. Moving on to the next question. Let's see what we have. The next question is also a question we're still solving for x. Now, with solving an inequality, the one thing you'll always hear me say is that you want to put your equation into standard form first, because once you put your equation into standard form, you will always be able to at least draw some form of an image that represents what your graph looks like. And as long as you have a picture to help you, you can use that picture to easily answer your question. So what I mean is, this graph here is a positive parabola. It's going to be a positive parabola that is smiling like this. That's the rough idea of what sketch we are thinking of when we look at this graph. It's an equation of a parabola, and because this is a positive number, we know it's a smiling parabola. This is representing our x-axis. What we know is this has one x-intercept on the left and another x-intercept on the right. This question is asking us, where is this graph above 0? Or rather, where does it have y values that are above 0? Because remember, this is the x-axis, right? Above the x-axis, you have positive y values. These are values that are above 0. And then below the x-axis, these are values that are negative, and these are values that are below 0. You see. So what we do know is this equation here, when we are writing it out, we know that all equations, they will be written as y is equal to something. So this question is asking us, where are our y values for this graph above 0? And alternatively, another question could easily be asking, where are the y values below 0? But without complicating anything and without saying too much unnecessarily in this video, this question is asking us, where is the graph above 0? And visually, the graph is above 0 over here. This is the part where the graph is above 0. And then this is the part where it's below 0. So it's asking us, what x values, right, is this graph above 0? So to answer that question, we have to figure out what is the x-intercept here and what is the x-intercept there. Which is why before we do anything, we have to solve for x first, so that we figure out what our x-intercepts are. Solving for x here, we can try to do it by factorization first. Factors of 3, right, that can give us a 2. That's not difficult. A 3 and a 1 can give us a 2. But then for us to get a negative 2, it has to be -3 plus 1. You see. Then you can have x here and x there equal to 0. So when you solve for x here, our x is going to be equal to +3, or our x is going to be equal to -1. So already what you do know is the first x-intercept here, because it's on the left, that's a -1. And this one is a +3. So with that being said, what we do know is that to then answer this question, where is this graph above 0? We know that our graph is above 0 where our x values are bigger than positive 3. You see, because as long as you can see here, all these x values that are bigger than 3, we can see that our graph is above 0. And then all these x values, where our x values are below -1, our graph is also above 0. So we're going to say our x value has to be below -1, or our x values have to be above positive 3. You see. So that's the long and short of questions like these, right? This is how you answer these kinds of questions. And you can leave your answer like this. Sometimes most people would want to write it all in one statement. They'll put x in the middle, and then you can say something like your x values need to be smaller than -1, but then those same x values need to be bigger than positive. This is another way that you can write it. Many ways to answer this kind of a question. In terms of your final statement, you can write it in many different ways. But working out the answer, you can use this method. Moving on to 1.2, we have to solve for x and y simultaneously. Solving for x and y simultaneously, we have a 5-mark question here. So the first issue that we can clearly see is that we have a fraction here and we have another fraction here. Now, most of us don't like working with fractions. So what you can easily do for yourself is the equation that looks simpler. Take that equation and put it into the one that looks harder. That's one thing you could do. But for 5 marks, and also seeing that we have fractions here, let me not overcomplicate things. Let's actually try and see how best these two can work together. So normally when you're working with fractions, let's deal with the equation with fractions first. With this equation, your best bet is to try and make it look a bit simpler, in the sense that you want to leave it in such a way that it will be easier to do maths with. So normally when you're working with fractions, the first thing you want to do is to make sure that your denominators are the same. Not necessarily on both sides of the equation, but sometimes only on one side first, and then you can include the other side. So what I mean is, this side here, since it is a 1, you can put that over 1. This side, let's try and make it into one term, because you see, there's a plus in the middle here, so it means you have two different terms. To make this into one term, the denominators have to be the same. So clearly, to make the denominators the same, this one we're going to have to multiply with y over y, and then this one, let's just put this in a different color. This we're going to multiply with y over y. This we're going to multiply with x over x. You see, because what's going to happen here is y times the 1 here is going to give us a y, x times y is going to give us xy here, 1 times the x is going to give us x. At the bottom, we're going to have xy. This is equal to 1 over 1. Now, because our expression on the left here already has a denominator that looks the same, we can put y plus x here, the bottom xy equal to 1 over 1. So with this being done, what I normally recommend is, if you have a fraction on one side and a fraction on the other side, your best bet is to cross multiply and end up with a statement that does not have fractions. So the bottom part here multiplied by 1, the bottom part here multiplied by the top on the other side. So we're going to have xy times 1, which is xy. Here we're going to have 1 multiplied by this. So it's just going to be y plus x. So if you look at it nicely, right, working with something like this would have been much more difficult if you were to just throw in a value of x or a value of y from the other equation. Because if you're already working with a fraction, it's slightly a bit more difficult to use. But then if it is in this format, what you've already done is, what you've just shown is that this equation here, you can just rewrite it like this. The reason for doing that is because when it looks like this, it is easier to work with. So let's actually label this equation number 1, because we can do that. This one, let's label it equation number 2. So it looks as though it is easier to make x the subject of the formula here. So in equation number 2, right, let's make x the subject of the formula. So it means this 2 here, we can take it to the other side. So x is going to be equal to 2y minus 2. So this is what we know x is equal to. So we're going to take equation number 1, we're going to throw it into equation number, we're going to take equation number 2 and throw it into equation number 1. So the way that's going to look is, wherever we see x in this equation, we're going to have 2y minus 2. So let's do that. So we have y here plus x, right? This is our equation. So wherever we see x, we're going to put 2y minus 2. So here we're going to have 2y minus 2. And then here where we see, where we see x, you see we have to put 2y minus 2. 2y minus 2. And then here, it's just our y. So now we can just solve for y. Solving for y, here we'll just have y plus the 2y, which is just going to be 3y, because the brackets are really not necessary. They're not going to do anything. So 1y plus 2y gives us 3y, and then we have minus 2 here. On this side, the y we can multiply inside, one after the other. So y multiplied by 2y, that gives us 2y squared. Y multiplied by negative 2, that's negative 2y. And then, from here, we can put everything on one side. So we have 2y squared minus 2y. This to the other side is minus 3y. This to the other side is going to be positive 2. And then, let's simplify everything. 2y squared minus 5y plus 2. This is something that you definitely just want to use your calculator in the quadratic formula. So the quadratic formula, y is equal to minus b, and then plus minus b squared minus 4ac over 2a. If you put in the value of b is a negative 5 there, and then negative 5 squared. The value of a is a 2, the value of c is also a positive 2. And then at the bottom here we have a is equal to 2. So the way it looks, just for 5 marks, it looks like this is overkill, honestly speaking. It does look like overkill. Funny enough, the way this looks and the way this looks, they look very similar. It makes me wonder what would have happened if we tried to make this equation look like this, because the way this looks, it looks like x is probably a 2. But let's just finish this and we can see another way we could have probably solved this question in a way that would have been slightly much faster and would have also saved some time. So for now, I'm putting everything into the calculator. Let's see what we're getting. Y is a 2. That's not too unexpected. So y is a 2, or let's see what the other option for y is. Or y is a half. Okay, that's not bad. So what that means is, in our equation here, where y is, we have to put a 2 first, and then we have to put a half afterwards. So to get our other answer, we can say x here is equal to, where y is, let's put a 2. This is like 2 multiplied by 2 minus 2. So that's a 2. And then the other option, 2 multiplied by a half, and then we have to subtract 2. So this is giving us 1 minus 2, which is minus 1. These are our 4 options for x and y. Actually, now that I think of it, it looks as though having just gone this route may have been the safe way to get all answers of y and x. It looks like the shortcut version may not have properly given us everything that we need. But that's question 1.2. 1.3 is the last question in question 1. So let's see what we can do here. This question looks very familiar. I know I have done it before somewhere, guaranteed. It also looks like one of the questions in the online courses on the website, most probably in the algebra course. I can almost bet on it. But anyways, given this expression, we have the left-hand side and the right-hand side, where m and n are integers. Determine the value of m plus n. So without overthinking this kind of a question, just work with what you have. See how best you can break down this kind of an expression to see what value of m you have and to see what value of n you have. So let's start. So I'm going to rewrite the question just so that I can see it a bit bigger. But this is what we have. So you may be thinking, okay, where do you start? Normally, in terms of these kinds of questions, you need to have gone through similar questions so that you have an idea of how to start. So in my mind right now, I'm thinking to myself, let me look for things that are common. So for example, these both have a base of 3. Of 2. These both have a base of 3. Now, what we do know is if your bases are the same and you are adding, oh, I was yawning, sorry. You don't exactly have much to work with if your base is the same and you're adding. So I'm thinking what to do now. And I haven't done maths in a while, so I'm also like not very sharp as of this moment. But let's see what we can do. So what am I thinking here? I'm thinking to myself, okay, fine. Here, what we do know is that the bases were the same, and we added exponents. So if you reverse that process here, you can end up with 2 to the power of m multiplied by 2 to the power of 1, and then plus 2 to the power of m. Okay, so I feel as though that was a good thing to do, because automatically what I can see is that in on the two sides of this plus symbol, we can see that there is 2 to the power of m, which is common. So that's a good thing, because we can take it out as a common factor. Let's do the same here. We have 3 to the power of n multiplied by 3 to the power of 2, right? And then here we can subtract 3 to the power of n. And in between them, we have a negative symbol here. So with 2 to the power of m, we can take that out as a common factor here. You have positive 2 here. If you take out 2 to the power of m, you have a positive 1 here. On this side, if you take out 3 to the power of n as a common factor, you have 3 squared here. If this is gone, you have 1 as a placeholder, just like what we did here. So fortunately, if you carry on simplifying here, this is giving you a positive 3. So you can have the 3 multiplied by 2 to the power of m. Here, this is 9 minus 1, which is going to give you 8. So you can say 8 multiplied by 3 to the power of n. So funny enough, this is where you do need to get a bit creative, because both sides, if they're equal to each other, then there are certain elements of both sides that have to match. Fortunately, there's already a 3 here and a 3 there. The exponent here is a 1, the exponent here is a n. On this side, there's an 8, this side there's 2 to the power of m. So if you can already see, this side you can rewrite it as 3 to the power of n first, and then or rather, let's do the other side instead. So the way things look, right, if it doesn't matter which side you want to rewrite. This side here, right, yeah, let's actually leave it the way it is, 3 to the power of 1, 2 to the power of m. This side on the other end, let's swap these two. Let's write 3 to the power of n first. The 8, we can write it as 2 to the power of 3, you see, because this makes our two sides look more identical, because where there's a 1 here, there's an n over this side. Where there's m here, there's 3 on this side. So automatically, n is equal to 1, and m is equal to 3. So when you will then answer this question, determine the value of m plus 3. It means that m plus n, is just the same as 3 plus 1, which is going to be equal to 4. And there's your 4 marks for this kind of equation. So, I mean, coincidentally, I have bumped into this kind of equation before. But the idea behind thinking of questions like this and how to break them up is the same. You want to look for something that is common. You want to break down equations bit by bit. And then before you know it, everything will fall into place. So question 1 that we have looked at, this is all linked to the algebra course on the course website. The link to that is in the description. See, algebra. It's an algebra course. It has about 5 chapters. Each of those 5 chapters will get you ready for question number 1 in your end-year exams. But for now, let me move on to question number 2. Question number 2. We're starting off with 2.1. 2.1, arithmetic series is what we're dealing with. So with an arithmetic series, we know that is fairly straightforward. We have an arithmetic series, the one that's to determine term number 91. With any arithmetic series, we have the formula on your formula sheet at the back of your question paper. And this is the formula for the general term of an arithmetic series. So the reason why we're using this formula is because this question is asking us for a specific term in the sequence. Hence why we're using the TN formula. So we are looking for term 91. It means wherever we see n, we have to put 91. A, we know it represents the first term. And then D is the common difference between any two consecutive terms. So here we have 12 minus 7, which is the 5. That's our value of D. So we have A, we have D, and we have N. So A is a 7, N is 91, G is 5. 91 minus 1 is a 90. So we have 7 plus 90 times 5, right? What is 90 times 5? 90 times 5 is about 450. Why am I even guessing? And I can just check with the calculator. but yes, it is 450. And then here 450 plus 7, 457. That's term number 91. Very straightforward question. The next question is asking us for the sum of the first 91 terms. So because this is S91, we have to use the SN formula for an arithmetic series. SN formula, you can get that on your formula sheet. N over 2, 2a plus n minus 1b. Now in this situation, the number of terms we're looking at is 91. And it's for the same series. So our a value is a 7. Common difference is a 5. Let's put all that into the formula. So S91, n is equal to 91, a is equal to 7, n is equal to 91, d is equal to 5. So simply put, this is just a 2-mark question. So you're better off just putting everything in your calculator and making sure that you don't make a silly mistake when you put all these into your calculator. So I'm making sure that my brackets are in the correct places. And the final answer here is 21,112. That's S91. Moving on to the next question, 2.1.3. Calculate the value of n for which Tn is equal to 517. So since it's a question that has Tn and it's arithmetic, you want to use the arithmetic formula, n minus 1d. Our a, we know it's a 7, d is 5, and in this situation, Tn is 517. So you have Tn here, you have a, you have d, you're looking for n. So to work this out, we have 517 here on the far left, a is a 7, n is what we're looking for, and d is a 5. So to solve for n, the 7 can go to the other side. It's going to be 517 minus 7, which is 510. Then here, 5 multiplied by n is 5n. 5 multiplied by -1 is -5. Solving for n, the -5 has to go to the other side. So it's going to be 510 plus 5, which is 515. Divide both sides by 5. Let's see what our value of n is going to be. 515 divided by 5, that's 103. There we go. So the best way to test this answer is to put 103 over there, put 5 over there, put 7 over there, put it all in your calculator, and you should get 517. The next question. Why are all these overlapping like this? But anyways, the next question, excuse me. The one thing you want to take note of is that it is 2.2, right? Whereas all these questions here were under 2.1. You see, we have 2.1.1, 2.1.2, and 2.1.3. So because this is 2.2, it means it's a new question on its own. You see, they told us here that term number 1 is a 3. Okay, so if T1, and as you can see, as I'm already reading this, I'm already starting to make notes. So T1 is a 3, meaning that the first term is 3. And then here they've said that T2 minus T1 is a 9. And then T3 minus T2 is 21. So already what I'm thinking is if I write T1 here, T2 here, T3 here, what we already know based on what we're reading here, T2 minus T1 is a 9. And then T3 minus T2 is a 21. Okay. And then we have T4, which we don't know, but then we have T5 somewhere. T5, they've told us that it is 111. So what we can actually do to modify this, let's replace this with a 3. Let's replace this with 111. So we have this here. There we go. Okay, this is quite... No. I made a mistake. They've not told us that it is 111. They say we should show that it is 111. And it's a 2-mark question only. Okay, that's not too bad. Well, the one thing that I made a mistake of doing here is I did not even read the question properly. I just jumped into wanting to solve it because they said the following information is given about a quadratic equation. So as long as we're dealing with a quadratic equation, it means that our sequence has a second common difference, meaning that here we have open space. Here we also have an open space. So what we fortunately already know is that here, between 21 and 9, there's a common number here, which is 21 minus 9. I mean, if you want, you can just use your calculator. It is 12. So you have a 12 over here, you see, meaning whatever this number is, minus 21 should also give you a 12. So to get this number, you can easily just say 21 plus 12, which is giving you 33. And then here also, 33 plus the 12, 45. There you go. So fortunately, you can always then just work backwards here, because 3 plus the 9 gives you this number, which is 12. 12 plus the 21 gives you 33. 33 plus 33 here gives you 66. 66 plus 45 gives you 111. So the fortunate thing is, as long as you can also even just draw out this diagram, that should be enough to get you your 2 marks, you see. And even just say here, there 45 for 111, because just the diagram here shows how you got your answer. And it is just a 2-mark question, so you don't need to overthink it. Moving on to 2.2.2. It says, show that the general term of the quadratic pattern is as follows. So we have to get a formula for this quadratic number pattern. So fortunately, you can actually just take this diagram and you can use it for the question that is asked below. Let me paste this here. Let me write it a bit smaller so that we have more space, because I can see I didn't give myself enough space there. So with this being said, right? But anyways, let's see. As long as you have your diagram laid out like this, remember what we know is that with the quadratic number pattern, what matters the most is these 3 numbers, because if you're going to get your general term, remember your general term says Tn is equal to An squared plus Bn plus C. What that means is we can start from the top. This or the bottom, this is always equal to 2a. This is always equal to 3a plus b. This is always equal to a plus b plus c. So in a situation like this, starting from the bottom, 2a is equal to 12. This is going to give you divide by 2, a is a 6. Second row here, 3a. A is already a 6, so you can replace the a with the 6. Plus b here equal to 9. 3 times 6 is 18. And then 9 minus 18, that's negative 9. The last one, a here is a 6. B is negative 9. C is just a C. And then 6 minus 9, that's minus 3. And then if you put the 3 to the other side, that's 3 plus 3, which is a 6. So you have A, you have B, you have C. So you can already see that looks exactly like what you should end up with. And you can just say, therefore, Tn is equal to 6n squared minus 9n and then plus 6. Then you can move on to the next question, which is 2.2.3. So because it is still 2.2, it means we should still be thinking of the previous questions that we have just worked out. It says here, show that the pattern is increasing for all values, for all numbers. Okay, let me translate this. Show that the pattern is increasing for all numbers that, what's the easiest way to put this? This means natural numbers. Natural numbers. Natural numbers are numbers that start from 1 and they are whole, and they're complete, they're full numbers. They're not fractions or anything. These are whole numbers all the way to infinity. So they say it shows that the pattern is increasing for all natural numbers, basically. Meaning, we should show that even though this is a quadratic number pattern, right? Starting from 3 going onwards, we should show that these numbers will forever be going up. We should show that there isn't a time when maybe dropping. So what's the mark allocation? It's a 3-mark question, and the best way to go about this kind of equation is to think of how a parabola behaves. You see, remember, a quadratic equation is a parabola. You see, so what we already know is that this is a parabola that is smiling. We already know the parabola is going to look something like this. What we also do know is that this parabola has a turning point somewhere. You see, because remember, there's a turning point here somewhere. After this turning point, all these numbers to the right, they are just getting higher and higher and higher forever. But then before this turning point, they were just getting lower and lower and lower and lower until a certain point, and then they started getting higher. So somewhere here, right, this number here could be the 111. This one could be the 66, and then the 33, and then the 12 going lower and lower and lower. At some point, there's a turning point. So what you can do for yourself is, let's find the turning point first. To get the turning point of any parabola, you use this formula: x is equal to minus b over 2a. However, in this situation, you can say n is equal to minus b over 2a, meaning that the value of b is a negative 9, the value of a is a positive 6. This is going to give you 9 over 12. And if you simplify this as best as you can, it'll probably like give you a third or something, or rather 3/4, sorry. So clearly, one way or the other, right? Your turning point is where n is equal to 3/4. You see, 3/4 is before 1. You see, 3/4 is before 1. So automatically what we know is, starting from the first natural number, which is a positive 1, where n is a positive 1, starting from where n is a 1, right, going all the way to infinity, all those numbers will always produce a pattern that is going higher and higher, because the only way where your pattern is getting lower is if you go the opposite direction of positive 1. But without overcomplicating this, here we can easily say n, let's see, we can actually put it in words. The turning point is where n is 3 over 4, and the smallest natural number is 1. Therefore, the pattern is increasing. Why am I writing in yellow? I'll change the color here. Is increasing for all numbers where n is a natural number. And then here we can see, because our parabola is increasing. You see, this is where you can take advantage of the fact that any parabola is just a quadratic equation. Or rather, any quadratic equation is just a parabola. Okay, let me just recolor this so that in case the white is a bit too much, let's change the color. Okay, whoa. Change style, please. Let's even make it black. There you go. So we can move on to question number 3. Question number 3. So it says here, given the geometric series with 3, 6, and 12 to a certain number of terms, for 1 mark, write down the general term of the series. So since it is a geometric series, the general term, we already know that we can also get it from the formula sheet. It is Tn is equal to A multiplied by R n to the power of multiplied by R to the power of n minus 1. So this is not a difficult question, because our first term is a 3. Common ratio is T2 over T3, T2 over T1. And then our value of n is just n. So in a situation like this one, we know that for 1 mark, the question is Pretty straightforward. Just close the door there. So get R, we know that it is just going to be 6 divided by 3 in this situation, which is just going to give us a 2. So 6 divided by 3, it is a 2. That's the value of R. So our general term here, 3 multiplied by 2 n minus 1. For 4 marks, we have here, it says calculate the value of k such that this equation is equal to 98,301. So with all that being said, let's see. We can already see that this is a geometric sequence. Fortunately, you have to remember that anytime you see, anytime that you see a sigma notation expression, you need to think of an SN formula. You need to think of a suitable SN formula. So we already know that this question needs us to use the SN formula for a geometric series because we're dealing with a geometric series question here. It's 3.1, you see, and this is 3.1.2, so it's still under the same question. So our SN formula for a geometric series is SN is equal to A multiplied by, this is where I need to use the formula sheet because I can already see myself making a silly mistake, but let's see. So let's put here R minus 1, the whole thing to the power of N over R minus 1. This is our formula for geometric series. So with all this being done, what we already know is that we have done all this because of that sigma notation. You see, we have done all this because of that sigma notation. So what we now know is that in this sigma expression, we need to figure out what Sn is, we need to figure out what A is, we need to figure out what R is, and we need to figure out what N is, because this equation here is linked to this expression. Fortunately, any sigma expression is always equal to Sn. You see, so we already know that Sn is 98,301. What we also do know is that in any sigma expression, the value at the bottom here and the value at the top here will always give us the value of n. You see, because remember, n is always where you're ending up minus where you're starting, then you plus 1. This is a general equation for sigma notation expressions. So the end here is the value up here, which is a k. The start is the value down here, which is a 1. If you plus 1, this is just minus 1 plus 1, which is just a 0. So it means that where we see n, we need to put a k there. Furthermore, we can easily write out our sequence here because of this expression. Remember, this expression here gives us our general term. You see, this here is the general term. So because we can see that general term, we can easily use it to get a value of A and to get a value of R. Because remember, if that's your general term, all you need to do is to write out the sequence, starting from where P is a positive 1, you see. So you're going to have 3 over 2, 2 to the power of 1 here. And then we know that this is going to give us our first term. Our second term is 3 over 2, the whole thing to the power of 2. Our third term is 3 over 2, the whole thing to the power of 3. So here we have the first term here is a 3. And then in this situation, this is just going to give us a 4. Okay, so this is not a difficult question because this is just going to give us a 6. And then here, this is 8 divided by 2, which is a 4, times 3, which is a 12. So fortunately, we can already see that this general term is just generating this series coincidentally. So already our value of A is a 3, our value of R is just 6 divided by 3, which is a 2. So we have all that, you see, which is important. We have A, we have R, we have N, and we have Sn. So we can easily then work out a value of K using our Sn formula. So carrying on, we can already see, remember where we see Sn, we say that is equal to 98,301. A is a 3, R is a 2, N is a K, R is a 2, and then here we have 2 minus 1, which is a 1. So here, because there's a 1 down there, this is just straightforward. 2 minus 1 is just also a 1. So this is quite a weird and odd question because there is nothing that we can do to the value of k for us to get the correct answer, unless I wrote this question incorrectly, because I keep thinking to myself, did I write down the SN formula correctly? You see, because the SN formula for a geometric series, I keep asking myself, did I write it correctly? And I didn't, you see, because the N here is supposed to be where the R is. And this is something that you already spotted a long time ago. But I failed to spot it because of my arrogance. I did not check the formula sheet. And this is telling us that the whole thing here has to be changed. It's not a big deal, but if you didn't spot it, you are just going to end up with a mistake. So here we can carry on. We can divide both sides by 3. This goes away. 98,301. If you divide this by 3, right, you're going to have 32,767 here. This is 2 to the power of k minus 1. And then you can take the 1 to the other side. It's going to be 32,768. And then if you want to have 2 as your base here, you can just use logs, you see, because you can say the exponent, you isolate it. It's always equal to log the base of your exponent, and then you put your number here. So here k is going to be equal to the following. Let's see. This is log with the 2 here, 32,768. This is going to give you k is got 15. And then that's your answer. You see, nothing too difficult over there, because why not? So all this that we have done, we can clearly see that it has given us an answer that is very believable to be the correct answer. But if you always want to test all this, you can just put a 15 where k is, and you should get the number on the left hand side. So if you do that, let's see there, 3 with 2 to the power 15 in brackets, and then 2 minus 1. Yes, you do get the number on the left hand side. So for 4 marks, this didn't look too bad. Let's move on to 3.2. 3.2 says a geometric sequence and an arithmetic sequence have the same first term. The common ratio of the geometric sequence is a third. The common difference of the arithmetic sequence is a 3. The sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. Calculate the value of the first term. So I downloaded this paper from Memo Physics, as you can see over there. That's no secret. You can also download past papers from that website. Anyways, having to have read this question, you want to keep in mind that because you've read the question once, it doesn't mean you should already start answering it. The best thing you can do for yourself is to try and sort out the information they gave you bit by bit. So they said you have 2 sequences clearly, an arithmetic and a geometric, but they have the same first term. So let's put it this way: split the page in half. Here we're going to have information about our geometric sequence. Here we're going to have information about our arithmetic sequence. So they said they have the same first term, right? So it means a for both of them is the same number. So we can put a. And then they say the common ratio is a third. So let's just put it this way: T1 in this situation is a, whatever a is. And then here T1 is exactly the same. They say the common ratio is a third, meaning that T2 divided by T1 should be equal to a third. In this situation, they say the common difference is 3. So it means T2 minus T1 is a 3. And then it says the sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. So in this situation, you are dealing with 2 formulas. So they said the sum of 22 terms of an arithmetic sequence, so it means you're using an SN formula for an arithmetic sequence, is equal. They say, you see, the sum of 22 terms, so meaning S22, right, of an arithmetic sequence is means equal to, so S22 equals to 734 more. It's 734 more, so more than the sum of, more than this, it's 734 more than the sum to infinity of a geometric sequence. So it means it is equal to 734 plus the sum to infinity of your geometric sequence. So if you read again, the sum of the first 22 terms of the arithmetic sequence is equal to 734 more than the sum to infinity of a geometric sequence. So whatever number you get here, it is equal to the sum to infinity plus 734. So that's your equation that you can use to calculate what they're asking here. So fortunately, we're using the SN formula of an arithmetic sequence. So it means we have to think of an SN formula here. N over 2, 2a plus n minus 1b. And then sum to infinity deals with geometric sequence. So a, 1 minus r. And then with all this being done, right, we need to write out the formula that we know is correct up here. So S22 first. So S22 would be 22 over 2, 2 times a, and then this is 22 minus 1. And your common difference, this is where you need to be careful. It's just the 3. So that's not a big deal. The sum to infinity in our situation here, a, we know it's just a, but fortunately our r is a third, you see. So we have S22, we have the sum to infinity. So we can just put them all in this formula. So in our formula, we can see that 22 over 2 is 11. And then we have 2 multiplied by a. We have 22 minus 1, which is 21, times the 3 there. So this is S22, right? We have just put this here, where S22 is. We know that it is equal to 734 plus the sum to infinity, which is 1 minus a third is going to be equal to 2/3. So it's a over 2/3. Excuse the background noise. So with all this being said, right, we need to solve for a. Solving for a here doesn't seem like a difficult question because here you have 11 outside. 21 times 3, that's 63. And then this is 734. And then here you have to be creative, you see, because logically all we're seeing here is a 1 in front here. So it is 1 divided by 2/3, you see. So you can just put that in your calculator. 1 divided by 2/3. It's just going to give you 3 over 2. So here we technically have 3 over 2a. And then moving on, we can see that here we need to multiply the 11 inside, you see. So it's going to be 22a plus 11 multiplied by 63. It's going to be 693. And then here, 734 plus 3 over 2a. Everything on one side, and I mean everything with a on one side. This is what we have. And then 734 minus 693 here. Let's see. 734 minus 693, that's equal to 41. So here, the kind of a number that we want as a first term or as a value of a, let's see what we're getting here. 22 minus 3 over 2. This is giving us 41 over 2. Okay, not bad. So to solve for a here, we're going to divide both sides by 41 over 2, 41 over 2. See. So in this situation, our value of a, let's see here, 41 divided by 41 over 2, our value of a is a positive 2. So this is quite a normal and acceptable answer. You know, if it was like a long decimal, it would have been a bit difficult to accept. But us getting a as 2, that seems correct enough, because if you want to check your answer, it may not necessarily be a very difficult thing to do, because in this situation, if a is a 2, it means that T2 is a 5. But you may be asking yourself, how do you double check if your answer is correct? Well, yeah, that is quite a good question. That is quite a good question. One thing you can do is, let's see, common ratio is the third. If this is a 2, then let's see, T2 over 2, 1/3. If you cross multiply, 3T2 is equal to 2, and this is equal to a third over 2. So it may be a bit of a mission to try and double check if your answer is correct. But the fortunate thing is, what you're better off doing is you can maybe for yourself just put a marker next to this question. You can just highlight it for yourself and then carry on with the rest of your paper, such that when you do finish with the rest of your paper, you can always come back here and you can always try and figure out a way that will make sense to you to double check if your answer is correct. But you may not want to do that before your whole paper is complete. Otherwise, you're likely to waste time trying to work on something that is already correct. So let's move on to question 4. Before moving on to question 4, what we've looked at right now, question 2 and question 3, it has been sequences and series. Now, most of these questions, they are questions that you may need more clarity on. The best way to get deeper explanations is to sign up for the sequences and series online course on the course website. The link for that is in the description. Question number 4. This is the first functions and graphs question. And let's see what we have to do here. So the first thing it says here, sketched below, is the graph of f of x. F of x is clearly an exponential graph because x is an exponent over here. And then it says here a and b are respectively the y and x intercepts of the graph of f. So you have a here, it's a y-intercept because it's cutting the y-axis. You have b here, it's an x-intercept because it's cutting the x-axis. Furthermore, it says that here, our exponential graph, we're only seeing it from -2 until 4. So the -2 here, it has a colored in dot to show us that the graph does touch -2. This open dot at +4 is telling us that the graph will reach just before +4. Hence why this bracket is round, and that's why this bracket is square. This is saying the -2 is included, the +4 is not included. With all this information, they say write down the equation of the asymptote of f of f. So fortunately, our picture is already showing us the asymptote, which is this dotted line here that the graph is not touching. Our equation also tells us the asymptote, you see. The asymptote is a -4. And you can see it's a straight line that is passing the y-axis. So we know this is a -4 because this number is -4 in the equation of our graph. So the equation of this straight line here is just y is equal to -4 because it is a straight line that is cutting the y-axis at -4. And we know this number is a -4 because it will always be this value in the equation of your exponential graph. That's why this is just a 1-mark question. Getting the coordinates of b shouldn't be too difficult because what we already know here is that the y value is a 0. The x value is all we need. We know the y value is a 0 because this graph is nowhere up. I mean, this point is nowhere up, it is nowhere down, it's at 0. So what you can do is, in your graph, where y is, you can put a 0. So you're going to have there 0 is equal to 2 to the power of x minus 4. Meaning that the -4 goes to the other side, that's going to be positive 4. And then 2 is the base, this is the exponent. Fortunately here you can easily see, to make these two sides the same, you can just put 4 with a base of 2. So here you can say therefore x is equal to +2. But then they asked for the coordinate of b, you see, so you have to be careful that you leave your answer like this for you to get your 2 marks without any issues. 4.3 says determine the equation of k, a straight line passing through a and b in the form kx is equal to something. Well, in this situation, they just want us to get the equation of this line here. It's going to be a straight line that passes through a and b. So what we do know is this coordinate here, this is a 3. Did we work it out to be a 3 or a 2? 2. And then we know that the value of a here, fortunately, we already know that the x values are 0. See, so to get the y value, we can just put x as 0 in the equation here. So in this equation, what we do know is that if you make x a 0, let's see what the y value is. Anything above 0 is a 1. So our y value here is going to be -2, which makes sense. So we have 2 coordinates, and we need an equation that passes through those 2 coordinates. That's quite straightforward because any equation of a straight line is equal to mx plus c. The value of m is always going to be the gradient between any 2 points that the graph passes through. So here we have -3 and 0, and then here we have 0 and 2. So what this means is we have x here and y, x here and y. So we have y1 and x1, we have x2 and x and y2. So our value of m here, we can easily say it's 2, or we can just say 0 minus 2, and then -3 minus 0. So this is going to be -2 over -3, which is 2 over 3. That's the value of m. And then in this situation, we can use this formula. Y minus y1 is equal to m x minus x1. Now this formula, it allows you to immediately get the full equation of your graph if you have the coordinate that the graph passes through. Our gradient is 2 over 3. X remains x. X1 we can use the 0 over here. Y1 we can use the 2 over there. Putting this in its simplest form, the -2 can go over to the other side, right? So here, if you multiply inside, it's 2 over 3x. This multiplied by 0 is just a 0. And then the -2 here is just a positive 2 there. They say they want our equation in this format. So you can just say here, therefore, kx is equal to 2 over 3x plus 2. You see, because the kx here just represents y. Here, what we know is all we had to do was to remember that any straight line has this format here. See, so you have to get a gradient that the graph is using, and then to get the value of c, we can always use this format. See, and that's how we got our answer. So that's 3 marks. 4.4 says calculate the vertical distance between k and f, where x is a 1. What that means is this is the graph of f, this is the graph of k. Now, where x is a 1, remember this is a 2 here, so x is a 1 somewhere here. You see? And if they want you to work out the vertical distance between those two graphs, they literally are asking for the distance here, from here all the way until there. That's the vertical distance. See, vertical distance between k and f. This is the distance they want. So to get that distance, all you have to do is you have to take the equation of f of x, and then you have to subtract the equation of k of x. That's literally all you have to do. And then in that equation, you have to throw your x value as 1. So simply put, we're going to take the equation of, it doesn't matter which one you start with, but let's start with the one on top, the equation of f of x minus the equation of kx, right? That's what we want. That's our vertical distance, you see. Vertical distance. So f of x, we already know it's this equation here of f. It is an exponential graph, 2 to the power of x minus 4. 2 to the power of x minus 4. And then we're subtracting k of x. You see, brackets are important so that you don't mess up. So this is 2 over 3x, and then plus 2. 2 to the power of x minus 4. If you multiply inside, you're going to have -2 over 3x, -2 here. Now, solving for x here may not be the easiest thing to do. But fortunately, remember we said all you have to do is your vertical distance. You're going to have to throw in 1 where x is, you see. So wherever x is, you're going to throw in a 1 over there. And then this is what we're ending up with. So we have all this, and we can put all this in the calculator. So it's 2 minus 4. 2 minus 4 minus 2 over 3 times 1 minus 2. It is equal to -14 over 3. -14, but that doesn't make any sense, you see. Because remember, distance should always be a positive number. So us getting what we're getting here, it's not a good thing that we're getting such an answer. So let me just double check what I see what we are getting wrong. The 2 here is wrong. Let's see, the equation of b is correct. Oh, I wrote it. Yes, there's the error. And here this is the error also. You see, I mixed up the value of a and I mixed up the value of b. I'm only noticing that now because of the follow-up question, and you may have noticed it much earlier. So Let me correct that. B here is 2 and 0. So these kinds of mistakes, they're quite detrimental. But one way or the other, if you make a mistake somewhere, fortunately, in a follow-up question, right, you're likely going to need to use what you used in a previous question. And if things don't add up somewhere, here, what we should have already seen is that the y-intercept here was a positive 2. That doesn't make sense because the y-intercept here should be negative 3. So this should have been an immediate red flag right from the beginning, you see, because in the equation of a straight line, already here we're seeing that our gradient, we can say 0 minus negative 3, and then 2 minus 0. This is going to give us positive 3 over 2. Now, what we do know is that our value of c is a negative 3. We know that because of this point here. That's a negative 3, because that's the y-intercept. So our equation, we're just going to say k of x is equal to the gradient, which is 3 over 2, and then the value of x gradient, and then minus 3. There we go. So in a situation like this makes better sense as the graph of k of x, because when we will now use it down here, things will make better sense. See, so let me use it in a different color to show that we made corrections. So here you have to subtract the equation of k of x, which we can see here it is 3 over 2 x minus 3. So if you multiply negative inside here, it's going to be 3 over 2x and then plus 3. Now if you throw in a 1 where x is, you're going to have 3 over 2 with a 1 here plus 3. And then with all that being done now, let's put everything in our calculator. 2 minus 4 minus 3 over 2 with times 1 here plus 3. That's going to be negative a half. Why is it still giving us a negative number ish? So yeah, it is getting a bit frustrating to be getting these answers. But then wait, maybe I'm the one that's making a mistake. Oh, the graph of f is under the graph of k. So yes, our distance is going to give us a negative number here. But then it's so annoying when I make so many mistakes. I apologize for that. In this situation, we can just swap the f of x and the k of x. The reason for swapping them is because specifically where x is equal to 1, we can see that the graph of k is on top. You see, I mixed them up here. The graph of k is on top, graph of f is at the bottom. So if you put it like that, we should get a positive a half, you see, instead of a negative a half. So k of x, we said it is 3 over 2x minus 3. Graph of f(x) is 2 to the power of x minus 4. If you put a 1 in this equation, you have 3, you have 1 here, you have 1 there, you have 3 over 2 minus 3. Multiply inside, you can have negative 2 plus 4. This should give us a positive a half, or maybe even a totally different answer, but let's see. 2 plus 4. Yes, positive a half. You see, so all these errors, they're quite annoying, I understand. However, what we can learn from them is that if there's one thing that's wrong somewhere, you will always be able to catch it if you double check your answers as best as you can. Because if you're getting answers that don't make sense based on what you're seeing, you should always question yourself, you see. So the first thing we should have questioned was that positive 2 that was here when we initially got the equation of k of x, because that was clearly wrong. So moving on to the next question, 4.5. Question number 4.5. It says here, write down the equation of g if it is given that g of x is equal to f of x plus 4. So it's clear to see why this is a 1-mark question, because we already know what the equation of f of x is. The equation of f of x, it is given to us up here. F of x, oh, oops, excuse me. Where is the pen? So f of x, we know that it is equal to 2 to the power of x minus 4. So let's just take this and Paste it down here. So if this is the equation of f of x, the equation of g of x is too straightforward, you see. G of x is just going to be equal to 2 to the power of x minus 4 plus 4, which is 2 to the power of x. And that is it. They say to write down the domain of the inverse of g. Okay, so a question like this needs you to just have a good idea of domain and inverse. I mean domain and range, and also needs you to have a good idea of how inverse works. So the best way to explain a two-mark question like this is the original graph of g of x. Visually, this graph of g of x will just look as follows. The asymptote is a 0. So this is where your asymptote would be. The y-intercept, you would make x a 0, which is just going to give you a 1. So visually, this is what the original graph of g of x looks like. The inverse of the graph of g is something that is very easy to draw, especially if you are familiar with how inverse works. What we do know is inverse, everything that has to do with x becomes everything that has to do with y. For example, the asymptote here is y is equal to 0. However, the inverse will have an asymptote here, you see, and it will also be going down. See, it'll be going down this way. This is the inverse of g. So simply put, if this is a positive 1 here, this will also be a positive 1. I think that's easy to see. Furthermore, if they're asking for the domain of the inverse, remember domain means where from left to right are you going to see the graph. So along the x-axis, your domain, right? Here you need to say that you're seeing a graph where your x values are bigger than 0. That's all you're going to say, because that's all there is to say. That's also just a two-mark question. 4.7 say write down the equation of the inverse in this format. So writing down the inverse is very simple. So here we have g of x is equal to 2 to the power of x, right? Now, I'm about to sneeze here, excuse me. The inverse, remember, all we need to remember is that x becomes y, and then y becomes x. There you go. So y here becomes x, and then the x here becomes y. And then we just have to get y as the subject of the formula. So to do that, we make y the subject of the formula, and then we use logs. Log, the base of y is a 2, whereas x is over there. It's an easy two-mark question, that's why we're not going to stress too much about it. However, if you want detailed explanations of all these questions that we are looking at, your best bet is to sign up for the online courses on our course website. The link to that is in the description. So let's move on to question number 5. Question number 5. It says the graphs of f of x and g of x are drawn. So f of x is clearly a parabola, and g of x is a hyperbola. It says here a point of intersection of f and g is b. They meet over here. They also meet over there, but they did not mention it. Normally, if they don't mention anything, it's usually not very necessary to give a lot of attention. I keep wanting to sneeze. Anyways, it says that the graph f has intercepts -3 coordinates 0, which is over here, and 5 coordinates 0. Then it says, and a y-intercept at c, which is over here. So what we can already see here is that this equation of f of x is in an important standard form. You see, a x minus p squared plus q. This is the standard form that we're looking at, and this standard form gives us an idea of what the turning point is. You see, the coordinate of the turning point. So our turning point automatically, we always take the opposite of x, but then with y, we keep it as it is. So this here is our turning point. It is information that our equation has given us. So we need to know that already while we are diving into this question. First question is asking us for the coordinates of the turning point. So this is a very straightforward question because they already know that the equation they've given us has given us turning points. 5.2 is asking us to calculate the coordinates of C. C, already we know that the x value is a 0. all we need to find out is the y value. And we have an equation of a graph that passes through C, which is f of x. In the equation of f of x, we're going to make x a 0, and then we have 0 minus 1 squared plus 8. There we go. 1 squared is a 1, or negative 1 squared is also 1. So here we technically have a half plus 8, which is clearly going to give us 8 and a half, which is 17 over 2. So this is something we can also just get in our calculator. Moving on, or before moving on rather, we have to give our answer as a coordinate, you see. Otherwise, you can easily get penalized. I see here I wrote down the same question twice. 5.3 says calculate the value of d. D is a variable in the equation of g of x, d over x. So in a question like this, we want to recognize that as long as there's no number here, the number there is a 0. We also want to recognize that where x is, as long as there's no number down there, that number there is automatically a 0. So these zeros here are already giving us information about our graph, which we are already seeing. There's an asymptote here. It's not drawn because it's running parallel with the y-axis here, and it's also here running parallel with the x-axis. So we don't visually see those asymptotes, but they are there. In our standard form is showing us that they are there and they are zeros. So with all that being said, fortunately what we know is that if you're going to work out a value of d, you need at least a coordinate that the graph passes through. And fortunately we have b. You see, we have an x value and a y value. So we can easily use that. Y value is 8, x value is a 1, and then here we have h is equal to d, or rather d is equal to 8. Let's write it like that. Therefore, d is equal to 8. So here, write down the range of g. So g is our hyperbola here. If you're going to write down the range of g, remember range is talking about values from top to bottom along the y-axis. This graph will go everywhere upwards until positive infinity. It will also go everywhere downwards until negative infinity. The only y value it doesn't touch is a 0. Otherwise, all positive y values, it has something for that. And then all negative y values, it has something for that. So our answer here, you're just going to say y is an element of R. However, y is not equal to 0. Then you're going to get 1 mark for that. And then he says, for each value of x, is this expression smaller or equal to 0? So the best way to understand this question is you need to know how to read it. All this is saying is if you take y values of f and you multiply them with y values of g, where will this expression, this mathematical expression, where will this expression be a number that is smaller or equal to 0? So logically what we know is for two numbers to be multiplied together and to give us a negative value, it means that one has to be a positive while the other one is a negative, or one has to be a negative while the other one is a positive. This is the only scenario that can result in us having a negative number. For us to get a 0, obviously we know one of them has to be a 0. So with that thought in mind, right, when we look at this graph, let me copy this graph here, let me bring it down here, and let me make it as small as I can. Oops, that is not what I planned. But I need to crop this though. I need to make it very, very small. But regardless of the size, I do need to make my point. So if you're looking at these two graphs here, the graph of f and the graph of g, what you want to take note of is the y values of these two graphs. So you want y values where one has positive y values while the other one has negative, and vice versa. So simply put, let's make red the negative y values of f. So this is where f has negative y values. This is where f has negative y values. And then alternatively, this is where f has positive y values. Let's do the same for g. This is where g has negative y values, and this is where g has positive y values. Remember, we want a scenario where they have y values that are not the same. whereas one is positive while the other is negative. So fortunately, you can see that starting from where -3 is here, right, up until 0, we can see that this graph of G has negative y values, while the graph of F has positive y values all the way until 0 here, right? And then that scenario only continues until 0. From -3 and just before 0, you have a scenario where you have negative y values here and positive y values there. Secondly, starting from 5, going all the way to infinity, actually, you have a scenario where you are going to have positive y values for G, while you have negative y values for F. So to answer our question, this is how we're going to put it across. We can see that from -3 up until 0. So here we can say x has to be bigger than -3, bigger or equal to -3 rather. And then x also has to be smaller than 0. So between -3 and 0, this portion of our question qualifies for this statement. Furthermore, the other portion that qualifies is from here, where x has to be bigger or equal to +5, but then x, or rather, let's just leave it like that. X has to be bigger or equal to +5, because that goes all the way to positive infinity. So let me write this a bit better. There we go. So with all this being done, let us carry on with the rest of the paper. Why did I write 5.5 again? Like, wow. 5.6. It says calculate the values of k so that this equation will not intersect the graph of G. It's a 5-mark question, so that's very interesting. So let's look at the graph of G. Or rather, let's look at this picture. Let's bring it closer to where our question is. So they have asked us this question because we need to use the picture they have given us previously. So they said calculate the values of k so that this straight line will not intersect G. So remember, I referred to this as a straight line because the format is the format of a straight line. It is important for me to refer to this as a straight line because it shows us that k is just a y-intercept. The moment we're able to see that k is a y-intercept, we can also recognize that -2 is the gradient. So automatically what we know is that the graph of k, or the graph of h, if it will not intersect G, it simply means that the graph of h can easily be any graph that starts here, but without touching the graph of G, obviously. And it can also then eventually be any graph right up until this second line here. So if you look at these two red lines, they basically represent the two, we can say the two perimeters, or the two highest points that the graph of H can go, and the lowest point that the graph of H can go. The graph of H can only be anywhere between these two red lines, but we know it has a -2 gradient. So what we do now about H is that if I draw a random line here, right, this pink line here, this pink line has a gradient of -2. However, k is the y-intercept. So initially here, the y-intercept, let's think of it as a 0. So k can be a 0 because as long as k is a 0, this graph will not intersect the graph of G. However, if k increases, which is our y-intercept, if the y-intercept keeps getting higher and higher and higher, you see the graph keeps moving higher and higher and higher. The graph keeps moving higher and higher and higher until this point here, you see, until just below that. That's the highest that k can be. The lowest that k can be is if the graph is moved all the way down here and it has this y-intercept. That's the lowest that k can be. So all they want us to do is to figure out what is this y-intercept and what is this y-intercept, because those are the highest and the lowest values of k that we can possibly have. Fortunately, to get those values of k, all you need to do is the following. It's a 5-mark question, so the 5 marks is not coming from what you will be thinking in your head, because there's a lot that you'll be thinking, but what you're going to write that will actually give you an answer that makes sense is not so much. All you want to do is, we need to get the equation of this graph here, which we can easily do. And then we also need to get the equation of this graph here, which we can easily do, because once we have the equation of this graph and the equation of this graph, we will easily have the y-intercepts of those two graphs. So for 5 marks, I don't want to think that this is just going to be swift, quick, and easy and straight to the point. But this is the kind of a question where if you bump into this in an exam and you know you're someone that gets 70s and 60s, try and do this kind of a question last so that you have more time to go through it without worrying about every other question that you would not have done. So the easiest way to go about this is the equation of this red line here. What we know about it is that it has a gradient of negative 2. What we need to know is what this point is. Now, without overthinking it, or rather, what I would much rather do right now is to pause and then think the question over and then carry on recording so that I don't say a lot of unnecessary information. So the solution that I have come up with, it is definitely outside the box, but since this is a grade 12 paper, we can use that way of thinking. So the first thing that we do know is that these red lines, right? Oof, salam, bad timing. What we do know is that these red lines both have a gradient of negative 2. So keeping that in mind, what we can actually do is we can take the graph of g of x, and then we can work out where does this graph of g of x have a gradient of negative 2. So to do that, we need the gradient equation of g of x. And to get the gradient equation of g of x, we need to differentiate g of x. Differentiating g of x is quite simple. We just have to change the format of g of x first. You see, we took the x upwards, so the exponent is a negative 1. And then, having to have done that, what we can do next is differentiating g of x. You are going to do the following. We know that differentiating the graph of g, all you have to do is, from here, we know that negative 2 multiplied by the 8 is negative 8. Then you remove 1 from the exponent. So this is the gradient equation of g of x. Now what we know is here, the gradient is equal to negative 2. So we can just work out what the x value is. Same here. So where we see gradient, we can put negative 2, and then solve for x. Solving for x, we can take the x of negative 1 down under the 8. And from here, we can actually cross multiply and solve for x. It's going to give us negative 2x squared, negative 8. And then we can divide both sides by negative 2. Negative 2, negative 2. Let me use a different. No, it's fine. X squared is equal to 4. And then here, if you square it both sides, you're going to have x is equal to plus or minus positive 2. So this is telling us that the x value over here is a negative 2, and the x value on the red line there is a positive 2. So in a situation like that, right, in the graph of g of x, we can just put x as 2 first, and then we can put x as negative 2 later to get two separate values, okay? Because all we're saying is the equation of h of x, it's this pink line, and it can be moved up or down. However, if it has an x value of 2, right, the y value, we can easily get it from the equation of g. And then if it has an x value of negative 2, the y value, we can easily get it from the equation of g. So let's actually do that first. In the equation of g, let's take negative 2 first, and then put that where x is. This is negative 4. And then if you put a positive 2, this is, what do we have here? This is a 4. G2. There we go. So with all this being said, what do we know? What we do know is we have two coordinates, negative 2 and negative 4, and then we have positive 2 and positive 4. So in a situation like that, what do we know? What do we know? What do we know? Let's just put in those two coordinates in the graph of h. So in the graph of h, what we know is x is a negative 2 first, and then y is a positive 4. And then this is plus k. And then here, negative 2 times negative 2, we have positive 4. And here it's saying k is equal to 0. Really? No, that doesn't make any sense. Goodness. Oh no, this is supposed to be -4. Oh, thank goodness. Yeah, so this would have been a -8. That makes sense. That makes better sense. And the other one, putting in this coordinate, it's going to be 4 here. -2 multiplied by 2 plus k. This is -2 times 2, that's -4. And then here, if the 4 goes over to the other side, that's a +8. So what we know is that if the graph of g, or rather if the graph of h is this first red line, this value is 8. If it is this other red line, this value is a -8. So the only way it can be a line that is between these two red lines is if our value of k is bigger than -8, but then k has to be smaller than +8. There's your final answer. So this was not a very straightforward question. So clearly you don't want to do it first. You want to do it last, or close to last, or rather last if it's not your cup of tea. 5.7 says h is a tangent to g. Okay. At r, a point in the first quadrant. Calculate t such that this equation intersects g at r. So just reading that question, it felt very annoying to read because it just, I get what they're trying to ask, but at the same time, I'm like, why are you asking questions that sound so repetitive? But anyways, they said here, if the graph of h is a tangent to g, if h is a tangent to g, right? Logically speaking, it means that h is this red line here. I need to draw this nicely. It's either this red line here or this red line over here. Both of these graphs can potentially be h. Furthermore, it says h is a tangent to g at r, a point in the first quadrant. So the moment it's a point in the first quadrant, it means that this one is out because this is the only first quadrant. And then it says here, r is a point in the first quadrant. And then it says calculate t such that this equation intersects g at r. Well, what is the equation of f of x? The equation of f of x is up here, right? So what do we have up here? The equation of f of x is this equation here, -1/2 and all that. Did I use, oh no, it means I made a mistake here because if this is a -1/2, it means that this would have been a -1/2, meaning that this would have been 7.5. You see, of which 7.5 is 15 over 2. Yeah, only noticed that now. Oh, hectic. But anyways, let's see here. The graph of f of x is -1/2 x minus 1 squared plus 8. And then you have plus t here. So they say this equation is the equation of y, right? They said here, calculate t such that this equation intersects g at r. Well, what we already know is that the coordinate of r is +2, +4. We got it from this previous question. That's very easy. So calculate t such that this graph intersects g at r. Well, that's not too difficult as it seems, because if you're going to calculate t here, calculate t such that this graph intersects g at r. Wow. Okay. Well, t is a graph that moves this parabola up or down, you see. So for this parabola here to be moved based on this number until it touches g at r, it means that the parabola has to move downwards. You see, the parabola actually has to move downwards. So it might move downwards and it will eventually potentially look something like this. See, this is what the equation of y is. You see, because t has moved it downwards until it is touching the graph of g. So we technically need to know how many units downwards would this graph have moved for it to touch the graph of g over here. So the easiest way to do that is this graph, regardless of what t is, it would have 2 coordinate 4 as a coordinate. So the y value will be a 4 and the x value will be a 2. So here we have here 2 minus 1, which is 1. 1 squared is just 1. So here we have negative a half plus 8 plus t, and then this is 4. So with this being said, right, we can just solve for t. 8 minus a half, that's 15 over 2. And then here, if you take the 15 over 2 to the other side, it's going to be 4 minus 15 over 2. What do we have here? 4 minus 15 over 2. 4 minus 15 over 2. This is giving us negative 7 over 2. So this is telling us that the graph has been moved about 3.5 units downwards for it to be touching the graph of G where R is. It's a 4-mark question. It just sounded a bit annoying to read, but these kinds of questions, there's plenty within the functions and graphs course on the course website, functions and graphs. You can sign up for that via the link in the description. Let's move on to question number 6. Anyways, this is question number 6. And fun enough, as you can see, I actually have finished the entire paper. And I am back to question 6, mainly because preference-wise, I'm not a big fan of financial maths. However, I did browse through the questions, and something that I noticed is that I know for a fact I've gone through all these questions before somewhere else, whether in the financial maths online course on the course website or in another paper. So the course website, however, I noticed that I left out the URL in the footer. However, the link for the online courses is courses.brightyoungbrains.co.za. You will find the full financial maths course. It has multiple chapters. It goes deep into financial maths from start to finish. It says here, question 6, Patrick deposited an amount of 18,500 into an account earning R interest per annum, compounded monthly. And then it says here, after 6 months, his balance is 19,319.48. Calculate the value of R. This is a very straightforward question. They don't come easier than this. It's a simple question where he has made a single deposit. So this is a simple compound interest question. So we can just use the compound interest formula. In this situation, we can see we need to get the value of R. The value of R is always over 100. This is what replaces I in our formula. And then here we can see that he deposited an amount of 18,500 that gained interest. So because the money gained interest, it means that this is the initial deposit, because this is the money before the investment has matured. This is the money after the investment has matured. So the value of the investment is 18,500. And then we can see that after the 6 months here, the investment is worth 19,000. Excuse me, 19,319.48. So the interesting part of this question is this interest is compounded monthly. So as long as your interest is compounded monthly, it means that where we see I in our formula, we need to be careful that down here where the 100 is, we need to have a 12. You see, because if your interest is compounded monthly, the value of R always has to be divided by the value of R percent always has to be divided by 12. So as a calculation, we can just put R over 100 times 12. The reason for that, just to go into something that may not be very necessary. Remember, anything with a percentage symbol, it means that it has to be put over 100. And then if you divide this by 12, you would have R over 100. Change this to a multiplication symbol. You have 1 over 12 here, and then this is how you end up with R over 100 times 12. This will be a value of I. All this being said, in our formula, we need to work out I. Our value of N, this is where you need to be careful. As long as it's compounded monthly, it means that the value of N is months, you see. So the value of n here is going to be 6. All this into the calculator, we have 19,319.48. This is equal to 18,500. 1 plus, we say here r over 100 times 12 as the denominator, all this to the power of 6. So if you're going to isolate r here, we need to just work step by step so that we don't make an unnecessary mistake. So in financial maths, it is a recommendation that you do not simplify unless you are working with the final answer. So in this case, the first step is to divide both sides by 18,500. And in a situation like this, you may want to make sure that you keep your numbers as they are. You don't want to break down anything into decimals because that will make things a bit difficult for you. So all this being done, the value of r, if you're going to isolate r, remember you have to get rid of 6 first. And to get rid of 6, you can have the surge symbol this side with the 6 over here, surge symbol on this side with the 6 over there. Now what's going to happen is on the right hand side, this cancels that. Then you have 1 plus r over 1,200. So we're doing this step by step, and this should not be overwhelming. If it looks overwhelming, it means that you need more practice. It means that you need to take time to go through more questions like these. And obviously, one of the best ways to do that is through the online course. However, carrying on here, right, we need to ask R, so the 1 can go to the other side. Let me just, I noticed I didn't give myself enough space for this question. Yeah, I didn't. So if the 1 goes to the other side, you're going to have 6 square root of 19,319. Am I writing that correctly? Yep. So with financial maths, you can see this is just a 3-mark question. But every mark counts. So you don't want to rush things and then make a silly mistake and end up losing 1 point or anything like that, because every mark counts. To isolate r here, we're going to multiply by 1,200 on both sides. Remember, the whole thing here gets multiplied by 1,200. So in your calculator, you have to be careful. We are going to put 2 brackets. Inside the brackets, we're putting the shift surge symbol, where the tiny 3 is. We're replacing that with the 6. And then it's 19,319.48 divided by 18,500. The whole thing here minus 1. And then what do we have here? So, oh yeah, we have to multiply this by 1,200. This is giving us 8.7, and then you can see there's 3 zeros afterwards, so we can already just round this off. This is going to give us 8.7%. So this is already in percent format, because remember, this value of r up here, we know that if you put 8.7 here and you are dividing it by 100, it's already 8.7%. So in this situation, we have gotten our answer. Or rather, don't put percentage symbol in your answer, actually. The reason you don't want to do that is here, if you put 8.7, that's good enough, which is all you need. Don't put a percentage symbol here, because it will imply that you have 8.7% here over 100, which will be wrong. That's like overshooting the runway. You already have the percentage symbol here next to your question, so the value of r is just 8.7. That's a small detail, yes, but just thinking about it is actually quite important. They wanted to calculate the effective interest rate here at 61.2. It's a 2-mark question. The effective rate interest formula, it's something to easily forget. So just make sure that when you walk into your exam, just remember it. Even if it's a matter of just opening your textbook briefly while walking into the exam room, just quickly checking what the effective rate interest is. It will help you because that's one of the formulas that are not on your formula sheet. However, it is a question that is always 3 marks. So let me try and remember the formula. It's 1 plus I effective is equal to 1, is it minus or plus? You see, so that's the dangers of not quickly browsing through your textbook but the fortunate thing is, if you have been studying and going through the past papers, etc., during the time period, it's very easy to be remembering these formulas. But on my side, obviously, since I haven't been doing maths for like the longest time, I am forgetting a bit. But if I remember correctly, this is a plus. And then you have I here again. It should be I norm divided by m, the whole thing to the power of m. There we go. The norm here is for nominal because you'll have effective rate interest in the formula and then you have nominal interest in the formula. So this is what your formula looks like. Now, our question, we know that our interest is being compounded monthly. So it means that m is a 12. And then here, since we're working out the effective interest rate, it means that they've given us the nominal interest rate, which we worked out in the previous question. It is just 8.7%. So with a question like this, if you isolate effective here, means that on the other side you can have 1 plus I nominal is 8.7%. If you're going to write down the percentage symbol, it's fine. Just make sure that in your calculator you remember to put that percentage symbol in your calculator so that your calculation will not be wrong. So 8.7 shift percent symbol over 12, the whole thing to the power of 12 minus 1. We have here 0.0, let's put 91. And then the reason for putting 91 there is because the moment you round this off to 2 decimal places, it means that you're going to have 9. Actually, no, let's not round it off to 3 decimal places. Let's actually make it like just a bit more. This would be 0.55. So to round this, if you multiply this by 100, to write it as a percentage, it's going to give you 9.06%. There we go. So the reason behind writing as many decimals as possible here, or rather quite a few decimals, is so that once we write this as a percentage, we can at least have the number or an answer correct to 2 decimal places that is accurate. Moving on. This question, as I said, very familiar. I've probably gone through a question like this or this exact same question quite a few times. These are some of the benefits of going through past papers because fortunately it's very difficult to always come up with something brand new. So there are from time to time questions that are recycled. It says here Kuda bought a laptop for 10,000 rand on the 31st of January 2019. He will replace it with a new laptop in 5 years' time on the 31st of January 2024. So the dates, usually there isn't too much that changes based on the normal way of thinking when you have multiple dates being mentioned in your question. That's one thing that they usually sometimes do to try and throw you off. But questions are usually straightforward, regardless of the dates they mention, because a lot of information that they'll give you will help you know what you should write. It says here the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. So this is very important because anytime they are talking about the straight line method, they are talking about simple interest. There we go. So with simple interest, it says, yeah, after how many years will the laptop be worth 0? So this is quite straightforward because your simple interest formula, 1 plus 1 minus actually, because something is depreciating here. 1 minus I times n. What I always recommend is write out the information for each of these variables before you throw into your calculator, before you throw stuff into your formula. It helps minimize errors. So if you think of it, your laptop is initially worth 10,000. So whatever your item is worth in the beginning, that's the value of P. Whether something is going to depreciate or whether it's going to gain value, where you are starting is always P. Then it says here, you will replace it in 5 years' time. That's fine. It means that our value of N is equal to 5. Because with simple interest, you can see that even in the question, they said per annum. Per annum means yearly. You see, so already it means your value of N is years. Unlike here, your value of N, we said it was months. You see, the value of N in this question was months because this was compounded monthly. Furthermore, so we have P here, we have N, and then the interest, we said it's 20%, so this we also have. Remember, it's not compounded monthly or whatever because it's simple interest, so I is just 20%. And then it says here, after how long will the laptop have a value of 0? So this is the initial value of the laptop. and then over time it goes down to 0. So they want us to work out, oh, oops, you see I already made a mistake here, because they said he would replace it after 5 years. This question is not saying that the laptop would depreciate to 0 after 5 years, because they're actually asking how many years it would take for it to depreciate to 0. So it may depreciate to 0 before the 5 years or even after the 5 years. It doesn't matter. All we know is Kuda wants to replace his laptop after 5 years. But this question has nothing to do with the 5 years. So let's leave n empty because we actually don't have n. So carrying on from here, a is a 0, p is 10,000, I is 20%, the value of n is what we're looking for. So solving for n here, it's quite straightforward. Funny enough, well, if you divide both sides by 10,000, you're just going to have the 0 on the other side. See, so you have here 0 is equal to 1 minus 20% multiplied by n. The 20% we can actually take it to the left. So this is like 20% with n over there as the variable, and then there's 1 here. So the way we are writing this out, you can see things are just straightforward. Maths will always be maths. The reason I'm saying it like that is because you can see that even though we have a percentage symbol next to the 20, we're still just doing algebra the way we know. So since we're solving for n, we're going to divide by 20% here, divide by 20% here, and then our value of n is equal to 1 divided by 20%. So in your calculator, you have to write out 1 divided by 20, and then you put the percentage symbol next to the 20. This is giving a 5. This is purely a coincidence that n is a 5. It is purely a coincidence, you see. So don't get confused with questions like this, because they told us that he wants to replace the laptop after 5 years, and then here they asked for n by asking us how long does it take for it to reach 0 if the value is depreciating. We got an answer 5, but that's purely just a coincidence. 6.2.2 says, Kuda will buy a laptop that costs 20,000 in order to, okay, let me full stop there. Kuda will buy a laptop that costs 20,000, full stop. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th of January, 2019. So this is a very important question. It says here, he will make his 60th monthly deposit on January 2024. The savings account pays 8.7% per annum, compounded monthly. So it means that I is going to be equal to R over 100 times 12. And then it says you calculate Kuda's monthly deposit into his account. What's very important is don't overthink a question like this, because first and foremost, they have given you quite a lot of information already, and it's just a formal question. So there's not a lot of overthinking that should go into this, especially when it says that his first deposit is the 28th of Feb 2019, and his 60th deposit is on the 31st of January 2024. So situations like these, right, don't overthink it. They've already given you everything you need here, in the sense that, firstly, this is a question where he's putting money aside every month and it's gaining interest. So a situation like that, it means that your formula should be the future value annuities formula. So f is equal to x, 1 plus I to the power of n minus 1, the whole thing over I. And then it says here, what do we need? Since we need the value of x, quite straightforward here. We can actually, let's see the information we have. F is 20,000 because that's how much he wants to accumulate towards. He wants to build his money. He wants his money to gain interest until it's worth 20,000. After 60 deposits, you see, he makes his 60th deposit on the 31st of January, and then it says here the savings account pays interest of 8.7%. Let's put this over 12. Or remember, we can write it as 8.7 over 100 times 12. It's the same thing, because remember, the percentage symbol just means divided by 100. You see, so a percentage symbol here, it means divided by 100. So you can write your value for I like this, or you can write it like this in the calculator without forgetting the percentage sign. But don't forget to write this in your calculator also if you use this. So with all this information, our monthly installment we don't know. One thing I always recommend, which you also probably saw in the financial maths course, is that it's better if you're going to work out the monthly installment, isolate x first. So meaning here you're going to multiply by I, multiply by I. Then you're going to have here fi put x 1 plus I, and then to the power of n minus 1. And then here, since you want to work out x, we can divide by this over here, and then divide by this over here. There we go. So it means that this cancels this, and then here we have x is equal to fi 1 plus I n minus 1. There we go. Okay, so what do we have here? So to work out a value of x, clearly we just need to put everything into our formula. So our value of f is to 20,000. 20,000. The value of I is, I like to write it like this, 8.7% over 12. And then here we have 1 plus 8.7% over 12. And then we have here, where is n? 60. There we go. Let's put everything in the calculator. Fraction 20,000. Then you have here 8.750%. 12. Then you have in here, what do you have? 1 plus 8.7%. Then you have 12 over here. This is to the power of 60 minus 1. Okay, this is very normal. It's a very normal looking answer because 267.26 rands monthly over 60 months. Yeah, if that money is gaining interest, it will definitely accumulate 20,000. That's very believable and doable. So this question for 4 marks, I believe we are good. Let's move on. 6.3 is a very, very interesting question, but it is also very straightforward because questions like these are very common. All you need to know is how to go about it, because the way to answer questions like these is the same all the time. It says here, Tino wins a jackpot of 1,600,000. Okay. And then it says here, he invests all of his winnings in a fund that earns interest of 11.2% per annum, compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 will Tino be able to make from his fund? As mentioned already, a question like this has a very specific way that you want to answer it. The way you want to look at it is that this 1,600,000, right? This money is gaining interest, you see. And then while it is gaining interest, you are withdrawing from that money every month, you see. So here you are reducing your balance, you see. Whatever balance you have in your account, as the money is gaining interest, you are making that balance go lower and lower and lower every month, even though this money is gaining interest. Now, a scenario like that, you need to remember that's exactly what happens when you take out a loan. When you take out a loan, that loan gains interest over time. However, as you paid off, the loan gets smaller and smaller and smaller. So even though here they did not say anything about a loan, it it's it does not mean that you cannot use the P formula. As a matter of fact, you should use the P formula in a situation like this, because all the P formula says is that a lump sum is gaining interest, but then at the same time, every month you are reducing the balance of that value. You're reducing the accumulated value of that amount, which is what we're doing here. So for us to work out what they want us to work out here, right? Which is how many withdrawals you're going to make until there's no more money in his fund. It's just a question that we need to almost look at as a loan. So the formula we're going to use is the P formula, which is x 1 minus 1 plus I to the power of n, the whole thing over I. And then in a situation like this, we already know that x is the monthly withdrawal, so it's 20,000. The interest is 11%, 11.2% per annum compounded monthly. So this we have to put over 12. It's very important that we do so. And then the value of n, what's the value of n? N is something we have to work out properly. And then the value of P is 1,600,000. What is important about this question is that we need to remember here, let's read carefully. He wins a jackpot, yes. He wants to withdraw 20,000 every month. And then he says his first withdrawal is exactly 1 month after his initial investment. Well, that's fine because, yeah, here and we don't have to do anything funny. We can just work it out straight. No complications here. We'll get a mark for this, definitely. So to isolate n, I have shown that in the financial maths course on the course website. However, to isolate n, this is what you do. You're going to firstly multiply by I on both sides. So you're going to have here pi is equal to x 1 minus 1 plus I to the power of n. And then both sides you're going to divide by x. Dividing by x on both sides, you're going to have pi over x. This is going to be leaving you with 1 plus I of n. And then to make n the subject of the formula, what you're better off doing is this whole part here. Remember, this is together. But then this part that we have put in a box here, it goes with this negative symbol. So what you can do is this part, take it to the left hand side so that it becomes a positive, because it's always easier to work with positive numbers. And then this whole thing here, take it to the right hand side. You see. And then isolating n, we can use logs here, because if you want to isolate an exponent, what you do is you isolate that exponent and then you make it equal to log. Whatever the base of the exponent is going to be what we refer to as the base of the log. And then this whole part is going to be up here. You see. So it's important for you to be able to do these kinds of isolations to isolate a single variable in a question, because this allows you to put everything in your formula and then just get an answer that is not wrong because you would have rounded off or something. This allows you to not round off. This allows you to be able to put everything in your calculator at once and then just get one big answer. So here you see, I wrote 11%, it's 11.2%. Small minor details like that, they're very, very important. So this P here is 20,000, and then the value of I is 11.2% over 12. And then, what do we have here? Remember, this is P20. No, that's wrong. P is X. I mean, 20 is X. P is 1,600,000. So again, concentration is important. This here over 20,000. So in your calculator, the way you put this is actually not difficult at all. You just have to be alert. So in your calculator, you're going to press the log button, the one that is under the on button, if you're using the Casio calculator. And then you're going to put your brackets, and then 1 plus fraction button, 11.2% over 12. And then in the other bracket, you're going to put 1 plus the fraction button. You're going to put 1,600,000. And then open brackets, close bracket, fraction button, 11.2 shift percent over 12. And then in the denominator position, we're going to put 20,000. All this in the calculator, we're getting the number 60.03. You see. So what's important here is, even though this number is a decimal, they're saying here how many withdrawals of 20,000. So here you can round off to the nearest whole number therefore, or rather always try and round downwards, because even if it was 60.8, the 60 is telling you that you have about 60 complete withdrawals of 20,000. The 0.8 is saying that one last withdrawal will be less than 20,000. So with that being said here, you want to make sure that as a conclusion right here, you can say therefore 60 withdrawals of 20,000 can be made. There we go. And that will be that. This is where your financial maths ends. And as mentioned, all these questions on financial maths, right, for you to have deeper explanations from start to finish on the topic, your best bet is to click the link in the description and sign up for the financial maths course. It is a course you're able to sign up for on a monthly basis, of which you can cancel your subscription whenever you're done with the course. Or you can just buy all the courses that deal with the entire syllabus all at once off for the year, that you can all find on the course website. Let us move on to question number 7. Because of this recording, I actually skipped question 6. But obviously, since you're watching this video, I already did question 6. But the reason why I skipped question 6 is, genuinely speaking, I'm not a big fan of financial maths. I don't like the way it makes me feel. It's just a bit annoying. But I'm doing question 7 first, but on your side, you already saw question 6. But I just want to finish the whole paper and then go back to question 5. Question 6. So here we're working this out using first principles. First principles is a very simple, straightforward question. Here we have f prime. It is always equal to lim h goes to 0. And then here we have f of x. What's the equation again? Am I forgetting the equation? Oh, goodness. I think it's f plus x. Fx plus h minus f of x over h. That looks about right. So in the equation of f, we are going to put x plus h where x is. So we're going to have here x plus h squared. We're just trying to simplify x plus h first, you see. So in doing that, we have here negative 4, x plus h again, negative 4. Then here we have x times x, right? X times h, x times h times h. So here you're going to then have negative 4 x squared. This is xh plus xh, which is 2xh, and plus h squared. So this is what fx plus h is equal to, you see. So having to have done this, you can multiply the 4 inside. It's going to be negative 4x squared, negative 8xh, negative 4h squared. And then, with all this being done, what we now know is we can throw everything back into the original equation. I'm actually use a different color to get one. So f prime here, right? We say it is equal to lim h goes to 0. And we technically have here this whole thing here, negative 4 this squared 8xh minus 4h squared, and then minus this equation. So if you minus that equation, it ends up with a plus, because you're subtracting f of x. And then carrying on, we know that this automatically cancels that. So lim h goes to 0, negative 8x minus 4h. So it's 4h squared. There we go. So here, if you take out h as a common factor, you'll have lim h goes to 0. Take out h as a common factor. Let's see here. There we go. Let's see here. Going on and on and on. Let's see. Lim h, take out 8, take out h as a common factor here, you have negative 8x minus 4h here over h. And then you have lim h goes to 0, negative 8x minus 4h. And then here you can throw in 0 as a, you can throw h as 0. So f prime here is just going to be equal to negative 8x. And then you're done. Pretty straightforward. Very long, a bit annoying, but it's 3 marks. For 2 marks here, they want us to determine f prime. F prime is going to be 6x squared minus 3. That's it, actually. Very easy. Weird, but what done there? Here, we need to rewrite our expression, and let's see what we have here. 7.2.2. Let's see here. 7.2.2. So if you're going to differentiate this, you need to write it in a different format. So first and foremost, the square root, the cube root of x here squared. This is how you can rewrite it. The 3 has to go under the 2 there. And then you have 2 to the power of negative 5 as your exponent. And then the first thing here is, now we can differentiate, you see. So if you're going to differentiate, you can say equal to this multiplied by 7, it's going to give us 14 over 3x. Remove 1 from here, it's going to give us negative z. Here, negative 5 times 2 is going to give us negative 10. To move 1 from the exponent, you have negative 6. And then that's your differentiated expression. You see, they didn't say anything about leaving your answers with positive exponents, so you don't need to worry about that. You can just move on. For which values of x will the tangent to this equation have a positive gradient? For which values of x will the tangent to this equation have a positive gradient? That's quite funny, but anyways, it's a 3-mark question. Without overthinking it, they're talking about gradient and the tangent. So what we do know is that this equation, it may draw a graph that looks something like this, a cubic graph. You see, something like this. Because as long as your values of x get higher and higher and higher, it means that this number here is high, but it will always be multiplied by a negative. See, and then whatever that number is, we're just going to add this. Yeah, this is what we can expect of it. But anyways, it says, for which values of x will the tangent to this graph have a positive gradient? Okay, so what we need to find out is, firstly, this equation, right? Its gradient equation will look as follows. Negative 2 times negative 3 is going to be negative 6. Then remove 1, then you remove 1 from the exponent. 1 times 8 is going to be 8, then you remove 1 from the exponent. So this is the gradient equation of f of x. So if they're asking us for which values of x will the tangent to this graph have a positive gradient, we don't have to worry much about the tangent. All we have to worry about is where will the gradient be bigger than 0. That's all we have to do. We just have to work out where will this value be bigger than 0. So meaning we have to work out where will negative 6x squared plus 8, where will this be bigger than 0. So remember, anytime you work out an inequality like this, you have to consider the image. So this is going to be a frowning parabola, you see. So this frowning parabola, they're asking us, where is it bigger than 0? So visually, it is above 0 here. This is where it's above 0. So you have to work out this x value here and this x value. So to do that, let's solve for x first. Negative x squared plus 8, where is this equal to 0? So without overthinking it, let's take the 6 squared to the other side, it becomes positive. Divide both sides by 8. Oh no, by 3, 6, sorry. And then technically you're gonna have to square root this. So it's gonna give you plus or minus square root of 8 over 6. So square root of 8 over 6. We don't even need to simplify this number because it's just too strange to look at. But it's like 1 point something. So what we know is there is positive square root of 8 over 6 here. No, that's going to be on the right hand side. And then there's negative square root of 8 over 6 on the left. This is what we know. So they're asking us where is this graph above 0. So it's from here until there, right? So you're going to say here your x values need to be bigger than negative square root of 8 over 6, but those same x values need to be smaller than positive square root of 8 over 6. Okay, sounds pretty straightforward for a 3-mark question. So let's move on to question number 8. As mentioned, this question I'm doing it before the official answer sheet is released, before the official memo. So if there are a few errors here and there, it's not intentional. I may not have seen it because I have nothing to double check with, but I believe the errors will be very minor. Let's move on to question number 8. Question number 8. So for 4 marks, we are asked to determine the turning points of f of x, and this is fx. It's a very strange looking equation, to say the least. Okay, but fortunately they've given us the factorized version. This makes our lives very, very easy, to say the least, because this is telling us the 3 x-intercepts of our our graphs. And let's see, determine the turning points. So determining the turning points of any graph, it's very simple. You usually differentiate your equation once and you make the equation equal to 0. So let's do that. You see, so f of x, we may use this part for other questions, but for now we want the original equation. Negative 4, I forgot the negative 10, negative x of 3 plus 6x squared minus 9x plus 4. So this equation was simply going to differentiate it. So that's like negative 3x squared, 3 times 6, that's like a 12, and then 1 times negative 9, that's negative 9 with no x there. The derivative of a constant, it just falls away. So having to have differentiated this, we're going to make this equation equal to 0. And then we are going to, what are we going to do? We are going to solve for x using the quadratic formula. X is equal to minus b to the 12 plus minus b squared minus 4ac. I do recommend that you do write the equation first before using it. So here, let's put all this into the calculator, see what the calculator gives us. So we have fraction button, negative 12 plus square root of 12 squared minus 4 times negative 3 multiplied by negative 9, 2 multiplied by negative 2. So the answer here is 3 over 2. That's what x is equal to. Or, let's check the other answer. Put a negative here, we're getting the 9 over 2. So those are our 2 x values. So to get the corresponding y values, which we do need, all you can do is to throw in, I get it now. Yes, sir. Man, determine the coordinates of the turning points. Well, that's easy. In the graph of f, we're just going to throw in each x value individually. So the first one is 3 over 2. So with 3 over 2x, that's what you get. 3 over 2 squared, negative 3 over 2 squared here, negative 3 over 2 here, and then plus 4. And then here, the next x value is 9 over 2. So you can have 9 over 2, negative 9 over 2 cubed, 9 over 2 squared, 9 over 2 plus 4. So all this being done, let's put all this into the calculator with 3 over 2 cubed plus 6 Did I put a negative? Why am I putting negative 3 over 2? Maybe it's messing things up for myself here. And I'm actually seeing this and I'm wondering, why did I put a negative? Maybe it's because this one is a negative, but that's not a good mistake to make. So let's see here. 3 over 2 and then plus 4. That's giving us 5 over 8. Whew. To be honest, these are the kinds of answers that don't leave you feeling very confident, you know? But fortunately, the way we're writing it, or the way we're writing the answers, we're writing them in a format that is acceptable as coordinates. So let's see the next value of x here, 9 over 2. Putting all that in the calculator, wherever x is, that's giving us negative 49 over 8. So this is one of those scenarios where, because there's no official memo that has been released, it's very difficult to take these answers as true, even though they look very weird. But the easiest way to verify is, let's just go through our question one more time. We differentiated once here, right? It looks as though we differentiated correctly. We made our differentiated equation equal to 0. There is my error. I knew it. There had to be an error somewhere, you see, because the answers we're getting, they don't exactly leave the person feeling confident. So let's go back to that drawing board over there. I should have just actually checked this answer when I had gotten those fractions. Fractions are not always wrong, but they should make you question what you did, you know, just even if it's for a small moment, because they're not very comfortable answers. But anyways, this is giving us x as 1, or the other answer is giving us x as 3. So we can just replace all this with 1. Let's replace this with 1, and then all these here, then I have to replace with 1. See? And then in the other one, we can replace them with 3. So this is 3, 3, 3, 3, 3. So with all this being done, right, let's see, we have negative 1 to the power of 3 plus 6 to the power of 2 there, and plus 4. This is giving us a 0. And then here also, if you put a 3 wherever 1 is, let's see here, this is giving us a 4. So this is very, very normal looking answer. So we can at least head on with a heart that is more at peace. So 8.2 says, draw a sketch graph of f, clearly label all the intercepts with the axis and any turning points. So drawing a graph, it's much, much easier now. Fortunately, this is going to help us as well, because this gives us the x-intercepts of our cubic graph, and we need those x-intercepts, especially since we're about to sketch our graph. So let's go down here. This graph of f, we know that it's already factorized in this format. So here we know 0 is equal to x minus 1. This is going to give us 2 of our x-intercepts. The other one, this bracket here, is going to give us another x-intercept. So here x is equal to 4. Here, remember, you end up with 2 brackets. Or rather, you can just do it this way. Square root this side, square root this side. Nah, not really. Let's just have two brackets that look like this. You see, because here it's just going to tell you x minus 1 is equal to 0, or x minus 1 is equal to 0. So this is telling me x is equal to 1, or x is equal to 1, or x is equal to 4. So what that means is, at positive 1 here and at positive 2, 3, 4, you're going to have x-intercepts. Now, the way this is laid out, you need to remember that your graph of f, it has turning points at 1 coordinate 0 and 3 coordinates. At 1 coordinate 0 and 3 coordinate 4. So in a situation like this, this is your first turning point. and the other turning point is at 3 coordinate 4, so that's like 1 2 3 4 somewhere up here. The other thing is your graph has a negative symbol here, right? And this negative symbol should tell us that the graph is going down first. You see, it's going down first. So it's going down first. Furthermore, this is giving us the y-intercept because it is our constant over there. So since this is a 3, is it a 3 or a 4? No, this is a 4. So it means that over here, we can expect to see our y-intercept, right? So this coordinate here is 0 coordinate 4. This coordinate here is 3 coordinate 4. This coordinate here is 1 coordinate 0. This one here is 4 coordinate 0. So with all this being said, your picture will look as follows. It will be going down, go up, then it will turn here, come back down. This is what your picture can look like. See, so this is the graph of f of x. Let's go to the graph of 8.3. It says, use the graph to determine the values of k, for which this equation will have 3 real unequal roots. So that's an easy 2-mark question because all you have to use is this picture. You see, this picture here is what's going to help you understand this question that we asked. First and foremost, anytime they speak of a root, you see here they're talking about roots being equal, roots being real, determine the values of k, right? For which this equation will have 3 real and unequal roots. Roots are x-intercepts. So if you look at the way your equation is looking right now, it has 2 roots originally. However, this graph, if you move it up or down, there's a certain instance where it will have more than 2 roots. For example, as long as you move this picture downwards, automatically it's already having 1, 2, 3 roots. And if you keep moving it down, it will always have 3 roots until it has 2 roots again. So the original picture looks like this. And in this original picture, we can already see that the highest y value up here is a 4. The lowest, the turning point here is at 4. The turning point here is at 0. So the distance here is like 4 units, you see, 4 units. So automatically, if you look at the question, the value of k, right, if you move k to the left, you're going to have negative x cubed plus 6x squared minus 9x plus 4 minus k equal to 0. So with that being given, you should already see that k is a vertical shift. You see, k just moves the graph up or down. So they are saying, how many units up or down do you need to move this graph for it to have 3 roots that are not equal? So the only scenario where that happens is if you move the graph 4 units downwards. You see, you can move it a maximum of 4 units downwards, and it will always have 3 roots. So you cannot move it more than 4 units downwards, and you cannot move it upwards in any way. So here, the lowest that the value of k here, right? The lowest that you can move this graph downwards is 4 units. So clearly the highest number here can be a 4, because it will be -4 that you're looking at, which will be talking about you moving your graph 4 units downwards. But then the moment this value of k becomes anything above 4, then we're going to have a problem, because it means you would have moved the graph more than 4 units downwards. So clearly k cannot be bigger than 4. So here we can say k has to be smaller than 4, you see. However, you cannot move, k cannot be any number that is, remember, you cannot move this graph any way upwards, you see. So let's see how that is going to look like. K cannot be bigger than 4. So K has to be smaller than 4, yes. However, K has to be, let's see, for you to move this graph upwards, right? The value of K here, let's see, if it's a 0, it means the graph does not go anywhere. If it's a -1, it means the graph would have been moved 1 unit upwards. So it means that K has to be bigger than 0. You see, so the value of K has to be a positive number that is between 0 and 4, because if the number is like a +1, it means that here you'll have -1, meaning the graph would have been moved 1 unit downwards. If it's like a 2, then it's -2. If it's a 3, up until 4. K cannot be any number smaller than 0, because if K is a negative number over here, it means that you have a negative and a negative, which is a plus, which will mean that the graph will be moved upwards. And if you move the graph anywhere upwards, it will not have 3 x-intercepts. Remember, we said the only scenario where this graph has 3 x-intercepts is if you move it downwards. You see, you can only move it just before 3 units, just before 4 units downwards. It will always be having 3 x-intercepts. You see, because you see, if you move it downwards, it has 1, 2, 3 x-intercepts. The moment it gets anything more than 4 units, it's only going to have 2 x-intercepts first, and then eventually only 1. You see, so our sweet spot is only between 0 and 4. So that's your answer for this question. Remember, all these questions, right, they may not be very straightforward, but this is where your online courses come into play on the course website. The link to that is in the description. The reason why I'm pointing this out is because as you're going through a past paper, you're going to face certain questions once at a time. Like you will only see questions like these like once in the paper. But then on the online courses, it's an entire course on functions and graphs and calculus, meaning that entire course will have multiple questions like this, which will give you an idea of how to work questions like this in the long run. Yes, I repeated the question. Let's go to 8.4. For 6 marks, it says the line g of x, right, is equal to the following. G of x is a straight line, right? G of x is equal to ax plus b. It is a straight line, right? It says the line g of x is equal to this is a tangent to f. Yes, at the point of inflection of f. Yes, determine the coordinates of g. The 6-mark question. So the graph of f, well, fortunately we have the picture, so let me actually use the picture one more time. So with this picture here, right, let's see what we can do. It says here the line g of x is equal to ax plus b. That's a straight line. It is a tangent to f at the point of inflection of f. So fortunately we know where the point of inflection is. The good news is your point of inflection is always the point right in the middle of your graph, and it is also the midpoint of your true turning points, meaning in between 1 and 3, the x value is a 2. In between 0 and 4, the y value is also a 2, coincidentally. No. Yes, I am correct, because, wait, let me just do this properly. So the midpoint of these two, remember, midpoint formula says x1 plus x2 over 2, y1 plus y2 over 2. So x1 is a 1, and the other one is a 3. y1 is a 0, the other one is a 4. So here you're going to have 1 plus 3, which is a 4, 4 over 2 as well. Yeah, I think I was just overthinking. So the point of inflection here is 2 coordinate 2. This is the point where your tangent is. You have a straight line here, right, that passes through this point. That's the graph of G. It's a straight line that passes through this point, somewhere like that. You see, they say here determine the graph of G. So firstly, we can get the gradient at this point. You see, so the gradient at this point, we just need the gradient equation of f, where the x value is a 2. The gradient equation of f, we have it up here somewhere. Let me just get it here quickly. In this gradient equation, which is our first derivative, we just have to throw in our x value as 2. You see, so we have here 2, -3, and 2 here, -9. So let's see what the answer is. Here we have negative 12, 24, and 9. So here we have negative 12 plus 24, that's 12. Minus 9, that's a 3. So with all this being done, this is saying that the x value is a 2. However, the gradient is a 3 there. So we have the gradient of our graph of G. To get the y-intercept, that's quite straightforward because we can use this formula. Y minus y1 is equal to m x minus x1. Gradient, we know it's a 3. One coordinate that the graph passes through, the x value, we know it's a 2. The y value is also a 2. Simplifying this, we have 3x minus 6 plus 2. And then here, negative 6 plus 2, that's 4. With a positive 4. I mean negative 4. So that makes sense because you see the graph is going down like this. So the y-intercept is going to be a negative 4. It's a 6-mark question, and you can see the way we worked it out, it was so seamless. It was so seamless, so straightforward, because it's something that we can easily work out. Why did I write Maths Online courses here? I should have put down the website. The website is brightyoungbrains.co.za. That's the website with the Maths Online courses. I think the PDF file, you can click on this link and it will take you to the online courses. But anyways, let's move on to 8.5. 8.5 says calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant. So it's this graph here. It's this angle. You see, that's the angle they want us to work out. Now that's easy to do because remember, anytime you need to work out an angle with the x-axis, all you need is the gradient of the line that you're working with. And the gradient here is positive 3. So what we know is our angle formula says m is equal to 10 theta. So here 3 is equal to 10 theta. And then we can have here shift 10 with the 3. Remember, we want an acute angle as an answer. So the only thing is if you put shift 10 and 3 here, you're going to get an acute angle, which is 71.57 degrees. There you go. So that's what you get over here. With all this being done, let's move on to question number 9. Question number 9 says the following. The diagram below represents a printed poster, and it is a rectangle. We have A, B, C, and D. Let's see, the diagram represents a printed poster. Yes, rectangle A, B, C, and D is the part on which the text is printed. So the text goes in here. And then it says here, let me remove all this. That's where the text goes. It says here the shaded area A, B, C, D is 432 centimeters squared. So 432 centimeters squared. Fine. With all that being said, let's see. The shaded area A, B, C, D is equal to 432 centimeters squared. And AD is equal to a certain number of centimeters, which we don't know. And then it says here ABCD is 4 centimeters from the left and right edges and 3 centimeters from the top and bottom of the page. 9.1 says show that the total area of the page is given by this expression. The total area of the page. So let's see. The diagram below represents a printed poster rectangle ABCD shows part of the printed. The shaded area is this much, going on and on. And then they said the shaded area is 3 and 4 centimeters from the edges, right? And then it says here that's the whole page is here. See, they want us to show that the total area of the shaded page can be given by this. So that's not a very difficult question, to be honest. The reason being, it's just a 3-mark question. So that's our first consolation. Secondly, this kind of an equation, you always want to use variables that are the same. Meaning, for example, if you're going to label this distance here x, you want to write everything else in terms of x. You see. So let's put here, let's use this 432 actually. Or rather, wait, what can we do? Let me not overcomplicate things. Let me not overcomplicate things, because why? Total area of the page is given by this. It's a 3 mark question only, so yeah, let's not overcomplicate it. Anyways, let's see. If you move it 3 upwards, 4 to the right, what are you gonna do? Well, okay, so what am I thinking actually? Let's give this shape dimensions. Let's label this x, and let's maybe label this y. But whatever we do, we need to be careful. So what can we do? Well, rather, let's put x and y where we have more information. Let's label this x. Let's label this y. The distance BC here. So if this is x, right, it means that from here to there, it is x plus 8. Because you have x over here, and then you have the 4 over there, you have the 4. From top to bottom, this is y. Then you have 3 over here, you have 3 over there. So that's like y plus 6. Okay. So logically speaking, what we do know is that the full area of this shape, what can we say now? It is going to be, it's a 3 mark question only, so I don't overthink this. And I also want to write x and, oh, yes, I got it. This middle shaded part, we know that the area is 432, but then 432 is equal to x times y, meaning we can write, we can make y the subject of the formula. So if you make y the subject of the formula, it means that y is equal to 432 over x, meaning that here, instead of us writing y plus 6, we can just write 432 over x plus 6. Okay, so that's what we have as the dimension here. And then this is what we have as the dimension here. So what we do know is, technically speaking, the area of that entire shape is going to be equal to length multiplied by breadth. There you go. This you can simplify until it looks like this. No, it's supposed to be x down here, not 8. So simplifying that, here we can just get our fraction to be 1. And then here we can just get this to be 1 fraction. For this to be 1 fraction, clearly we're going to have to multiply by x at the top, x at the bottom. See here, let's multiply by x over x. So it's going to leave us with x plus 8 over 1, and then 432 over x, like that. So the top part here, right, you're going to have, here you have to multiply carefully, because remember, if you're going to multiply the top part, you have to look at it like this: x plus 8, 432 plus 6x. Remember, this whole top times this whole top, this is what it's going to look like. And then at the bottom, you're just going to have x, you see. However, since we want to make it look like this, what can we do? Let's get on and see where we end up. So here we can say x times the 432. Sure. Goodness. Okay, let's get on. It's going to be 432x. X times this is going to give you 6x squared. 8 times 432. 432. That's like 3,456. 8 times the 6 there. Let's see. That's going to be 48. And then, if you simplify this some more, fortunately, these two are like terms. So you have 432 plus 48. You have 480. So this, let's rewrite it the way they've given it to us. So we have this here first in the front. And then we technically have the 6x after it. The 6x squared. Let me actually write this a bit lower. A bit lower here. And then this plus this gives us 480x. the whole thing over x. So if we put everything individually over x, it's going to be this over x. This here divided by x gives you one single x left because 1x counts as 1x. And then here, 1x counts as 1x, you can have 408. 80 only, you see, because if you were to put each of them individually, you see, if you put this over x, this over x, and this over x, this is what it would look like, you see. But then, fortunately, you can see 1x cancels 1x there, 1x cancels 1x there. That's how you're ending up with your expression like this. And then plus 480. Moving on to the next question. Determine the value of x such that the total area of the page is minimum. So we have the area formula here. It's not too bad. So 3, 4, 5, 6 over x plus 6x plus 480. So where is the area minimum? Without overthinking it, you're just going to work out where is the first derivative equal to 0. So the first derivative, before you can get there, you have to rewrite this in a way that you can easily differentiate. So to do that, the x goes up, negative exponent there, and then 480 over there. Differentiating here, you're going to have negative 3, 4, 5, 6, whole thing to the power of negative 2. Differentiating this, you have a 6 only, this falls away. Where is the first derivative equal to 0? This is the question you have to work out, you see. And to work out, you have to solve for x here, right? To solve for x here, the x of negative 2. You want to take it down here, then it becomes a positive. And then this 6, you can take it to, let's take this actually to the other side so that it becomes a positive. And then this is 6 over 1. And then this, if you multiply the top there, this, if you multiply the top there. This is going to be 3, 4, 5, 6 equal to 6x squared. And then here, divide by 6 on both sides. You can have x squared. 3, 4, 5, 6. 3, 4, 5, 6 divided by 6. That's 576. And then if you square root both sides, let's see what you have. X is equal to plus or minus. Let's see what you get here. Plus or minus 24. Now, logically speaking, x is a length, so it cannot be negative. So x is a 24. Let's move on to question number 10. A and B are independent events, right? So the probability of A is a third, the probability of B is 3/4. Then it says determine the probability of A and B. Okay, if they're independent events, it means that the probability of A multiplied by the probability of B is equal to the probability of A and B. That's for independent events. So you're going to just say here, a third multiplied by 3 over 4. This is the probability of A and B. That says just a 2-mark question. So this is just going to be a quarter. That's the probability of A and B. So here it says P, at least one event occurs. The probability that at least one event occurs. Okay, how many marks is this? 2-mark question. The probability that at least one event occurs. Oof, I feel like I'm already overthinking this question. The probability that at least one event occurs. Let's see. 2 marks question. Well, it's a simple, straightforward question, but because I haven't done this in a long time, my mind is like, wait, what? So let's see, probability of A, probability of B, probability of A and B. Okay, let me draw some form of a diagram to help me here. So if I draw a Venn diagram, right, and I put 2 circles, I put here A, put here B. What we do know is the probability of A happening is a third, meaning that this plus this has to give us a third. And then the probability of B happening is 3 over 4, meaning this and this has to give us 3 over 4. So let me actually do it this way so that you can understand. Everything to do with A has to give us a third in total. everything to do with B has to give us 3/4. So fortunately, what we now know is that the probability of A and B is a quarter. So in the middle here, we have a quarter. So meaning this side just going to be a third minus a quarter. Let's see what we're getting here. A third minus a quarter. That's 1/2. So this is 1 over. No, this is 1/12. Sorry. Here, 3/4 minus a quarter, that's leaving us with 2/4. So this is what you have. Remember, this is a scenario where everything adds up to 1, because this is a Venn diagram of probabilities. So let's see. You have 2/4 over there, plus a quarter in the middle over there, plus 1/12 over there. Everything adds up to 5/6. So meaning outside here is 5. I mean 1/6. See, because all I did was added all this up and I removed them from 1. The remainder is 1/6, because everything here should add up to 1, because this is just a Venn diagram of all the different probabilities that can happen. So this is saying what is the probability that at least one event occurs. So the probability that at least one means both of them can occur, only one can occur, only one can occur, or yeah, the probability of at least one, it means that either A can occur on its own, either B can occur on its own, or A and B can occur together. That still counts as at least one. So the probability that at least one probability occurs is 1/12 plus 1/4 plus 2/4, which is 5/6. You see, because that's the probability that at least one event occurs. Then the next one here, it's a different question. That's 10.2. So 10.2 means that we're done with 10.1. Everything to do with 10.1, we have to disregard it because it's a new question. It says the probability that it will snow on the Drakensberg Mountains is 5%. So this is the probability that it will snow. It is 5%. 5% is 5/100. Writing it like this makes it just a bit easier to, to deal with. When it snows on the mountain, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 72%. So this is adding quite a bit to this question. It says, so this is more like saying if it does snow, then the probability that the minimum temperature in central South Africa will drop to 0 degrees is 72%. And then it says if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0% is 35%. So all you want to recognize is that these guys are feeding us with a lot of text, because it's almost like a tactic to try and just flood our brains with too many things. But this question is not that difficult. We're going to have to do a tree diagram. And you can see here, it represents the given information in a tree diagram, clearly indicate the probabilities associated with each branch. So initially, in the beginning, right, one of two things can happen. It's either going to snow or it's not going to snow. You see? So here is the probability that it snows. This is snowing. This is no snow. So the probability that it snows is just 5%. You see? Meaning the probability that it does not snow is 95%. You see? And then they say if it does snow, right? When it snows, it means that if it snows, one of two things is going to happen, right? If it snows, the probability that the minimum temperature is below 0% is 72%. So here, let's say below 0 degrees, and then here this is not below. Okay, so if it snows, the probability that the temperature will drop below 0% is 72%. I mean 72%. The probability that it will drop below 0 degrees is 72%. So this is 72/100, meaning the probability that it will not drop below that is just going to be 20. Mathematics, 28%, right? Yeah, because 100 minus 72 is 28. Yes. In this situation, they've told us that if it does not snow, right, it means that, again, chances that the temperature will go below 0 degrees is, you see, if it does not snow, the minimum, the probability that the minimum temperature in the central South Africa will drop below 0 degrees is 35%. So here it's 35%. This is 65. This is your tree diagram. Now, with this tree diagram, they say we should indicate the probabilities associated with each branch. So here this is snowing and below 0. So this is snowing and below. This is snowing and not below. This is not snowing and below. This is not snowing and not below. So these probabilities here, remember, it's just multiplying one probability with the other one. So 5 over 100 times 72 over 100. That's 9 over 250. And then 28 over 100. That's 7 over 500. And then here, 95 with 100 here. 35 and 100. This is 133 over 400. The next one, this is 65. Wait, what did I put? I think I put the wrong one. I put the wrong thing here. I may change this actually, because I don't remember what I wrote there, but it felt like it was wrong. Okay, so we have here 95 and this 35, 133. Oh, that's correct. Ha, but it just feels strange because everything here should add up to 1. So, oof, that's very tricky. Let's see if it does add up to 1, because it looks very weird. And if it does not add up to 1, then it means that it's definitely wrong. Plus 133 over 400 plus 247 over 100. Wow, it adds up to 1. Very interesting. So that's our tree diagram. It makes the next question very easy because it says you calculate the probability that the temperature in central South Africa will not drop below 0. So the probability that it will not drop below 0. Fortunately here, this is saying not dropping below. This is saying not dropping below. So it's going to be this probability plus this probability. And because of our tree diagram, we can easily just have here 7 over 500 plus 247 over 400. This is giving us the following. This is 7 over 500, and then this is 247 over 400. This is 1263 over 200, but then in its simplest form it is 0.6315, and then as a percentage, which is equal to 63.15%. 10.3 says, so 10.3 is a new question, right? We're done with the snow stuff. It says 10 learners stand randomly in a line, one behind the other. Okay, in how many different ways can the 10 learners stand in the line? Well, that's very simple because it's 10 people. How many ways can 10 people sit? It's just going to be 10 factorial ways. You see, because you have 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positions. When they are all not in a line, there's 10 options here. Once one person goes in the front, there's 9, and then 8, and 7, and then 6 going onwards. You see. So, with this being said, that's why we know the answer is just 10 factorial. 10.3.2 says calculate the probability that there will be 5 learners between the 2 youngest learners in the line. What? This is quite funny. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So without overthinking it, right, all we know is there are 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they say calculate the probability that there will be 5 learners between the 2 youngest learners. So logically speaking, all you want to do is, you don't overthink this. You can already think to yourself, assume that this is like one of the young learners. there has to be 1, 2, 3, 4, 5 people between them with this other young learner. So there are two youngest learners here, young number 1, young number 2. You see, let's put y1, y2. And then there has to be 5 people between them. You see, these can be 5 random people. So this is quite an interesting question, because the way you're going to think about this question, all you need to think to yourself is there has to just be 5 chairs between these two people, and then the rest they can sit whichever random way they can sit. So that's basically where your 4 marks are going to come from. You need to logically think of a way that these two people can be 5 seats apart, because it says calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So logically, this is scenario number 1, where there are 5 chairs in between them. And then scenario number 2, I think for this kind of equation, I have to draw out all the scenarios. Scenario number 2 is 1 young learner sits here, the other one sits there. You see. And then scenario number 3, you can already see where this is going. Fortunately, we're not limit like a lot of people. We're just limit 10, so we can work this out manually. Third scenario, one of them sits here, and then 1, 2, 3, 4, 5. The other one, wait, 1, 2, 3, 4. I missed one here. Yeah. Put this here. There you go. So in this situation, let's see. 1, 2, 3, 4, 5. Then you have one here. Then another one. You have 1, 2, 3, 4, 5. Let's see here. So let's see. This is the last scenario, right? 1, 2, 3, 4, 5. There we go. So these are 3 scenarios. 1, 2, 3, 4. Okay, why did I say 3? These are the 4 logical scenarios where the 2 young learners can sit apart. Obviously, we know that there's a scenario where they're obviously like swapped, where this one is here and that one is over there. But let's not think of that yet. Let's just think of this scenario that we have just drawn out, you see. So with that being said, hectic. Yeah, this is pretty hectic. But anyways, logically speaking, how you're going to go about this is, if you remember from the probability course, what we can think of is, manually speaking, if you're looking at scenario number 1, it means that for this position here, right? Let me remove this so that I'm somewhere to write. Do this. So to work this out nicely, all you can think to yourself is, in position here, in this position, you can think of it as there's only one option that can sit over there. And then remember, you have, once one option is set there, right? Or rather, no, man. In this first position, you actually have 2 people that can potentially sit here. The first young one or the second young one. Once one of the young ones sit here, there's only one option for this other slot. Okay? So one person is set here, one person is set there. You now have 8 people in total. Of those 8 people, there's 8 options for this seat. Once one person sits here, there's 7 here, and then 6, and then 5, and then 4. And then here, there's 3, 2, and then one option for the end there. And then logically speaking, the same process repeats. In a situation where the young one is over here and the other young one is over here, it means that the first young one, when both young ones are standing up, there's 2 options for this seat. Once one of them sits here, there's only one option for that seat. And then we have 8 people standing. Of those 8 people, there are 8 options here, and then 7, 6, 5, 4, 3, 2, 1 option. Scenario number 3, same idea. 2 young ones, we have options for this seat. Once one of them sits, the other one can only sit there. And then 8 people standing. 8, 7, 6, 5, 4, 3, 2, 1. Lastly, scenario number 4. One young person sits here, or one young person sits there. So when they are both standing, there's 2 options here. Once one of them sits here, there's only one option for the last one. And then 8 people standing. 8 options here, and then 7, 6, 5, 4, 3, 2, 1 option. Now, these scenarios, right? We know that to get all the seating arrangements here, it's just going to be these numbers multiplied by each other. You see, which we already know it is just 8 factorial multiplied by 2 times 1. And it's the same for all these scenarios here. right? 8 factorial multiplied by 2 times 1. And then here, 8 factorial multiplied by 2 times 1. 8 factorial multiplied by 2 times 1. So we have 8 factorial multiplied by 2 times 1 4 times, you see. 8 factorial multiplied by 2 times 1. These are all the number of ways that the young ones will sit 5 chairs apart. So let me just put this in the calculator. So this is a total of 322,560. However, they said what is the probability of that happening? So clearly, the probability of that happening is 322,560 over 10 factorial, because 10 factorial is all the number of ways that your seats can be arranged. And this is the number of ways that the young ones will sit 5 chairs apart. So the simplest form of that answer, it is just 4 over 45. Whew. Okay, so this is quite an interesting question, but I think we have done it justice. Let's calculate the probability that there will be 5 learners between the 2 youngest learners in the line. Yeah. So this is the way to work it out. You can see that you don't want to just keep it in your head, because if you keep it in your head, you won't solve it. If you draw it out, it's easier to solve. So this is the entire paper. The entire paper 1, 150 marks. We have gone through probability just now, and a probability course is on the course website, of which the link is in the description. Here I should have put down the URL. The URL is just www.brightyoungbrains.co.za. See, that's the URL. And then this is just my IG handle. You can always ask relevant questions that you may have based on what we have explained here and based on the online courses. I highly suggest you sign up for the online courses, because all that is pre-recorded material that will help you learn the entire syllabus from start to finish at your own pace. So that's that. I'll catch you in the next paper.